Hello, good afternoon. Hello, everybody. Thank you for coming. Thank you for coming to what is a second of our programmes related to water, resilience and innovation in the built environment exhibition. I hope you've had an opportunity to look around the exhibition in our main galleries. If not, there will be an opportunity after the talk today to have a look around. So please do. And please do share it on your socials and in your network. We are dependent upon everybody talking about this exhibition and getting it out there to the larger professional and public audience. So for those of you who don't know about the Building Centre, we are an independent forum for the construction industry. We're a non-for-profit organisation sitting below the Built Environment Trust. We run a continual programme of exhibitions looking at subjects around the built environment, subjects which we think are important and we need to educate and inform others in the marketplace. But we also deliver much more here. We are the home to over 40 businesses, businesses such as the head office, the UK Green Building Council, statutory bodies such as Construction Industry Council, trade associations like Timber Development UK, and a range of other bodies and organisations all working within the built environment. We have some in the region of about 40 different product exhibitors in the centre. We run a product directory which is free to access for both professional and public people. And we also deliver a lot of events here at the Building Centre. So over the course of the year, if you looked at last year for 2025, we delivered or hosted over 385 separate events, large conferences, CPD events, a wide range on a wide range of sort of subjects for the built environment. So it's really important for us as that non-for-profit that we work with and we collaborate with others in the built environment. This programme around water, the exhibition and the conference programme has been supported by the companies shown here, and we do thank them because without their support this delivery would not be possible. And I'll just do a quick bit of housekeeping which I've forgotten. One, can you make sure your mobiles are switched off for the benefit of all our speakers today? And secondly, there are no planned fire drills today, so should you hear a continuous ringing, please leave the room the way you came in, and the Building Centre team will take you out of the building. So today's programme is all about managing rainwater better, managing it where it lands. We need to think of water as a vital resource, and we need to reuse it locally and put it back to the environment as close as it lands on our buildings. We have got an absolute stellar cast of speakers for you today, experts in the industry. To start off the proceedings today, we've got Nikki Roach from Blue and Green Consulting, who will set the scene around the subject of rainwater harvesting. Followed that, we've got Lutz Johan, who will give a range of sort of presentations of various case studies that have taken place, followed by Sam Burgess from SDS Infrastructure that will be looking at the product solutions that are out there to deal with this management of water. We will then have a short comfort break around about 3:30. I should say, if you've got any questions on the back of Lutz and Sam's presentations, please hold them to the end, and then Sam and Lutz will take the stage and you can ask the questions then. We'll then have a short break for refreshments. There'll be teas and coffees outside, and then we go into a panel discussion that will be chaired by Kat Moncrief from CIWEM. So to begin with, and to just start proceedings off, I'd like to just quickly introduce Nikki Roach. Nikki is a director of Blue and Green Consultancy Limited and the host of Planet Possible, which is an award-winning nature and climate podcast. Nikki is one of the UK's leading specialists in water-sensitive design, sustainable drainage and blue-green infrastructure. Nikki's work spans policy, planning, practice, helping local authorities, developers and design teams translate ambitious sustainability goals into practical deliverable solutions. Through Blue and Green Consultancy, Nikki has played a key role in shaping how we think about water in our towns and cities, not as a problem to be engineered away, but as a valuable resource that can enhance places, support biodiversity, and build climate resilience. Nikki is also deeply involved in national guidance, research and industry collaboration, and is widely respected for her thoughtful, evidence-based approach and her commitment to improving outcomes for communities and the environment alike. So will you please join me in welcoming Nikki to the stage? Thank you.
I don't know who wrote that bio. It wasn't me, but I'm going to pay him a lot more money. That was fantastic. Thank you. Thank you, John. I'm going to work from notes. I hope that's all right. Because I'm a bit nervous, you know, you guys are a tough crowd. So good afternoon. I am Nikki Roach, and John's done a better job of introducing me than I could possibly do myself. But it is my real pleasure to be here this afternoon. I spent my entire career working in and around water, inside utilities, from strategy and delivery, water and waste. And it honestly remains a genuine privilege to work with people who are definitely not in that sector for the money, you know, who do it for the love and who do it because they are passionate and committed. And today I want to talk about, water reuse and rainwater harvesting, but I don't want to start with technology or regulation or targets. I want to start with a story. And I should warn you up front, it doesn't have a happy ending yet. About 4 years ago, my husband and I decided that we had one more house move in us. We bought, perhaps inadvisedly, a small, damp 1960s bungalow in Leeds. Over the next year, with a brilliant team of contractors, we turned it into what we hoped would be a genuinely low-carbon, low-water footprint, future-ready home. We were intentional about our choices. We prioritised technology that was innovative and environmentally responsible. And as our architect warned us, those choices came with trade-offs. For 2 years, we had no proper garden. I still don't have any wardrobes, and the front of the house looks a little like Steptoe's yard, which only some of you of a certain age will get the reference for. Why? Because the money went into our air source heat pump, into mechanical ventilation with heat recovery to help us manage the humidity through the house and capture the energy. Into solar panels, we even reorientated the roof so that we could squeeze 4 solar panels on because we were the wrong orientation. It went into smart automation across the home so that our windows open and close and our blinds open and close in order to manage the climate. And it went into a 5,000-litre rainwater harvesting tank buried in what feels like bedrock. We needed a very big JCB in the front garden, designed to feed our toilets, to feed my washing machine, and I did say my then, actually it's ours, definitely, and the irrigation system that I plumbed in myself, I'm very proud, in the back garden. Dual plumbing throughout the whole of the house, and 30% of our total annual demand covered by the water that falls onto our roof. 85% of our wastewater needs for toilets and the washing machine managed by our rainwater. Our plumber, our architect, our builder loved it. None of them had ever worked on anything like this before. In fact, I was remarking to John earlier on, the builder got so excited, he tried to convince me I needed a thermal mass in the middle of the house as well, and I should definitely have a ginormous tank in the central atrium he was designing for us. And I had to remind him it was a modest 4-bedroom home in North Leeds and not a grand design. They all loved it. They'd never done anything like this before. The builder knew, though, and he said to me, I'm going to have to do more of this, so I better start learning. The plumber was probably 4 years out of building college and said, I need to learn how to do this, so let me learn with you. And the architect thought it was amazing and has now got several Passive House accredited architects working for him because he sees where the direction of travel is going. We made the right choices, or so we thought. Today, this morning, my entire house is fed by mains water. I'm very grateful to Yorkshire Water for it being available, for it being clean and being extremely cheap. The rainwater harvesting system is still very much plumbed in, but it's not working. and I don't know why. I found out because my husband happened to walk past the rain director control panel, squeezed at the back of the garage, and there was a tiny little red light on it. I have no idea how long that red light has been on. In fact, the whole of my house is smart automation. I could tell you which individual spotlights are on in which rooms at any one time. My 8-year-old hates it because I know when he's got the light on and he's reading far too late. But I didn't know this wasn't working. I didn't know I was back on mains water. We phoned the manufacturer and they said, yeah, we can come and have a look, but it'll cost you £500 for us to come. My plumber doesn't really know what the problem is and so doesn't really know where to come back and fix it. And they did send me a replacement control panel and it didn't make a difference. And the simple truth is this: even if the system were working perfectly, the payback financially on water savings alone is around about 24 years. And that doesn't include the installation costs of the JCB that I needed to break into the rock in the front garden. So, I warned you, there's no happy ending yet. Side note, Lutz might be able to help me, he said before we came on stage. This is all just a ruse to get my rainwater harvesting system fixed. Yeah, sorry, Lutz. Yeah, absolutely. Just grab some water. Okay. But as you've probably picked up, I am an enthusiastic advocate for rainwater harvesting. In spite of what I've just told you, I talk about it proudly. I have a podcast, Planet Possible, where I fundamentally talk about optimism and solutions and what's possible, as John said, across water and nature and climate. I live and breathe this stuff, but I don't often tell this part of the story. Because here's the brutally honest question we have to confront. If someone like me, pretty informed, a career in the water sector, pretty motivated, I lived without wardrobes or a decent front garden for 2 years to be able to afford to do this. Somebody who is enthusiastic. If I can't make this work easily or affordably, how can I, in good conscience, recommend it to anybody else? And that leads me to my first key point today. If we are serious about water reuse and rainwater harvesting, we have to make it easy, reliable, and worthwhile for people to adopt and, crucially, to maintain. Not heroic, not niche, not nice if you can afford it. Easy. And I'm not giving up on my system. Okay, so the other part of my professional life when I'm not hosting a podcast is spent working inside water companies, helping them shape things like their drainage and wastewater management plans, which are 25-year investment plans, working out where they're going to spend money on drainage and wastewater infrastructure. And then what I'm doing at the moment is helping a water company deliver on those plans. A core part of those plans is about slowing the flow of rainwater into the sewerage network and, where possible, keeping unnecessary water out of the network entirely. You will have all seen, unless you've been living under a rock for a little while, in the press, plenty of news about pollution to rivers, about combined sewer overflows spilling significantly more frequently than we probably all agree is acceptable. What we don't talk about often enough, in my opinion, what isn't getting cut through, though, is the root cause of that issue, which is rainwater. We're trying to store the rain in a network that is not designed to do it. Looking into a water company, you might wonder why they're not more focused on stopping rainwater getting into their networks. You may have seen the announcements of spending $56 billion over the next 25 years in the water sector to do exactly that. And make no mistake, the water sector are absolutely focused on reducing spills from storm overflows, from emergency overflows, reducing dry day spills. They are absolutely focused, regardless of what you might read in the press. But how much of that $56 billion is being spent on managing rainwater at source? Or is the bulk of the investment going towards relining sewers, which fundamentally moves the problem somewhere else in the network, or building storage tanks? Water companies are trying to solve the problem of storm overflows when the bigger picture, in my opinion, is about managing rainwater. This isn't a criticism of the water sector. I love the water sector, and I will happily say that to anybody who wants to throw rocks at it. It is imperfect, but is very lovable. but it's been designed and it's evolved over 40 years since privatisation to not be set up to deliver rainwater management at anywhere near the scale that we need. Why? I mean, you could probably write the list yourselves. Our supply chains are dominated by traditional infrastructure. Our asset ownership blurs between homeowners and developers, highway authorities, local authorities, water companies, and none of us, if we're really honest with ourselves, values rainwater. Add to that a sector under intense public and media scrutiny, not unjustified, and you have an environment where taking risks, trying a solution that might be a little less certain, feels a bit too risky. At the front line, there are people fighting hard. I can see some, if I look around this room, to push sustainable drainage, rainwater harvesting and reuse solutions. They are evangelists for this stuff. They are absolute leaders, but they are still the exception and not the rule, because the enablers aren't in place yet. Okay, so let's flip the argument. We cannot build enough tanks across the sewerage network to store our way out of increasingly extreme rainfall. We'll keep the construction industry very busy, and some of you may be very pleased about that, but we cannot store all the rain that's going to fall at the rate that it's going to start falling. We cannot also push responsibility onto developers and householders and hope that water company compliance and spill reductions magically follows suit. And we cannot rely on goodwill alone. So we need a different framing. We need, in my opinion, a radical rethink. Here's the question I want you to think about today. How do we create genuine demand for water reuse and rainwater harvesting? Not tolerance, not obligation, demand. How do we make people say, I want a house with this? We need to make this part of our development. This is how I make my business more resilient. Because once people want something, we are very good at overcoming barriers. Affordability, regulation, supply chains, operating models, skills. Certainly in the case of my plumber, he's desperate to learn, but how does he? Those all get fixed after demand exists, not before. So what values can we tap into? How do we create that demand? Maybe it's lower bills, maybe a clear economic argument for harvesting and reuse. 30% of my demand can be met by rainwater, but it makes the tiniest difference to my water bill because I'm paying standing charges. And also, if you really think about it, how much do you really pay for water in the first instance? Somebody said to me earlier on today, I think my Sky subscription is probably double my monthly water bill. That says a lot about what we value. Maybe it's reduced flood risk. If you're in an area that's prone to flooding, you're probably already thinking about that for you and your neighbours. Maybe, if like me, you're quite a keen gardener, which is why 2 years without a garden was heartbreaking, maybe you don't want to spend all that money on plants, only to watch them shrivel and die throughout the whole of the summer. That was one of the reasons I wanted a rainwater tank, so that I could in good conscience keep things alive when I wasn't allowed to use a hosepipe, and we spent until November in Yorkshire under a hosepipe ban, so I was very grateful for it while it was working. Environmental responsibility. Maybe it's just a feel-good factor. For some people that will really chime. For us, we made a very bad financial decision to put this 5,000 litre tank in. It didn't make any economic sense at all, but it made us feel like it was the right thing to do, and I stand by that decision. Maybe it's about climate resilience for people's communities. We don't really need one answer. We need many tailored to different people. Okay, I'd like to draw a parallel, if I may. Put your hands up if you drive an electric car. There's a few, yeah. Of those, keep your hands up if you only started driving that electric car in the last 2 years. I'm surprised. I thought there might be more. I think there's been a real change in electric car driving. We've had one for about 8 years, and when we bought our first one, I'm not joking, my friends thought we were a bit mad, to be honest with you, because we didn't do a hybrid. We went straight for it. We were like, right, that's it. I got rid of a very, very nice car. I was a proper petrol head, and we went to a straight electric, and we knew it was the right thing to do. Does it sound familiar? There's a pattern in my life that's like making bad decisions with my conscience. Anyway, So I got the car. The charging infrastructure was not great. The range was limited. The conversations with our friends were lively. It did go very fast. I mean, to be honest, that was one of the pull factors for me. But today, it's very different. Huge choice. Pretty solid infrastructure. And there are no performance compromises. And I mean that because if you like driving, you can find an electric car that will give you, you know, McLaren P1 performance, but in affordable family saloon. It's great fun at traffic lights, but I stop at 30, I promise. Anyway, are there still affordability challenges? Yes, of course there are. But demand exists in a way that it didn't probably 8 years ago, maybe not even 5 years ago, but because demand exists, the system keeps improving. The charging infrastructure keeps improving. We're finding ways to do lamppost charging for houses that don't have drives. We're working those problems out. But why? Because people are asking for it. Friends of mine who would guaranteed have never considered an electric car told me about 3 weeks ago, very subtly, that that's what they're thinking about getting next. And a little part of me had a little moment, but I didn't tell them. But none of this happens by accident. It happens by design, yeah? I recently learned about an organisation called Your Energy, which, if what I'm about to tell you is interesting, come find me afterwards and I will tell you more about them. Fascinating presentation. A company in York that's developed a concierge service for domestic energy upgrades. If someone expresses an interest in solar panels or heat pumps or better insulation, but doesn't know where to start, this service acts as a single point of contact and guides them all the way through. It recommends trusted installers, that it's checked. It helps customers make decisions through things like free home energy audits in the first instance. And this is the one that I thought was particularly cool. It tackles financial barriers directly. They've partnered with a mutual society to create an unsecured financial loan, recognising that sometimes it's access to capital rather than interest. That's the real blocker for some of these solutions. The project started with Innovate UK and York City Council. It's now a functioning business as of last year, 600 customers engaged already, 42 completed projects. I think that is really fascinating, and it made me think, why are we not doing something like that with water? It's helped real customers take action, it's helped them navigate a complex landscape, and it's got in there and thought, what are the barriers and how do we then give a solution to customers? It's demand creation in practice. And I want to touch really briefly on water reuse at scale. I know we're talking at householder and development level here today, but the UK is a little behind the curve internationally on adoption at large-scale water reuse. Our February Planet Possible episode, just a small plug there, is all about reuse. Okay, so we've got examples from the UK, from Cambridge and Havant Thicket, which is the new reservoir, the first of 10 new reservoirs being built in the UK down south. Really interesting proposal to use water reuse as part of that reservoir. In the US, both direct and indirect potable reuse has been operating at scale for decades. And if you, like me, didn't know what the difference between those is, indirect, you treat your wastewater and you put it into something like a reservoir and you allow natural processes to do a little bit more work and then you re-abstract it and treat it. Direct is where it gets really interesting. Straight out of a wastewater treatment works, reverse osmosis, granularly activated carbon, some really interesting processes, and then back into a water treatment works to put it into supply. And the US have been doing it for 20 years. They apply that advanced treatment, they make sure they meet bathing water consents in the Pacific by taking out the nutrients, and they reuse that as fertiliser. A beautiful example of the circular economy in action. The questions we ask about householder development and system level public health and safety and trust, they dealt with that 20 years ago. And the lessons that I asked them, and I won't tell you all because I'd like you to listen to the pod, build trust. Show, don't tell. So create some demonstrators. Keep talking to communities. Acknowledge the things that they're worried about and make sure you work with them and stay anchored in the science. And John's very warm introduction to me talked about me being really bothered about evidence. And I just think our conversations, particularly in the world we live in at the moment, need to stay grounded in evidence. There is no technical reason why we can't do the same in the UK. We might need to think about energy costs, but at some point we will see large-scale water reuse happening. So those of you that know me know that I like to say everything is connected. It is, but we don't always act like it. Culturally, if you work in the water sector, we still see clean and dirty water. Water resources over there, wastewater over there. If you move, like I did, from one side to the other, you have defected to the dark side. It's a joke, but it's real. Flooding, drought, pollution, leakage, they're treated as separate problems with separate funding sources, separate 25-year plans. We have a water resource management plan and a drainage and wastewater management plan. 2 different teams in 2 different directorates, possibly even in 2 different buildings. Separate relationships with stakeholders, separate solutions. But in the reality, this is all about volume of water, the timing of when that water falls, and the location of that water in the landscape. Volume, timing, location. We understand that instinctively. If I talk to you about where you live, you could tell me a bit about water in your environment. You could tell me where there's always a massive puddle when you walk into the train in the morning and there's drainage is not great in that spot. You could tell me what happens to the local pond in the summer. You will know when your garden floods. We all know, we're instinctively connected to water in our landscapes, but our organisations don't reflect this in the way that we do business. Imagine I said that problem statement again, but I just changed the word separate to connected. Connected funding drivers, connected 25-year plans, connected relationships with stakeholders, and connected solutions. It feels different. It's a subtle shift in language, but it could make a ginormous change to the stories that we tell. Until we have a true rainwater management strategy, something a wonderful gentleman called Matt Wheeldon from Wessex Water talks about all the time, one that treats water as a resource in both wet and dry weather, until we have that, we will keep missing opportunities to build real climate resilience. And that's fundamentally what this is all about. It's about climate resilience. So my final challenge to you is this. Have a look around the room and think about who isn't here. Who are the voices that we haven't yet engaged with? Is it developers who don't see the value? Is it home buyers who maybe don't know what's possible? Is it finance providers or insurers or community leaders? Perhaps it's urban designers or planners or architects, or perhaps it's our future generations who, if you asked small children, and I have one that asks a lot of questions about this kind of stuff, why do we flush our toilet with drinking water at the moment? Well, my answer's easy. It's because the rainwater system's not working, Poppet. But, as a fundamental question, it's nuts. Pharmaceutical quality product that takes hundreds of people to produce, that we then flush down the loo. So what do you need from those people? In your corner of the system, wherever you've come from today, you've come because you care. You might pretend you don't. Maybe you've come for the biscuits, but you've probably come because you care. So my call to action is this. What can you do in the bit of the system that you're in to help create demand from those people that need to hear this? Because this cannot remain an add-on conversation. This isn't a set of nice to haves. This is about true climate resilience, managing rainwater where it falls. But there is hope. The Enabling Water Smart Communities project, some of whom you will hear from today, some of whom you will have seen on the big screens upstairs. And just as a side note, I had no idea my head would be on that big screen. So if any of you have seen the side of my nose on it, just don't talk about it. They are doing genuinely astounding work, right? I'm not just blowing smoke. It's brilliant. They are decoding many of the barriers that I've touched upon, right? Really practically, from public perception to delivery models to community and household reuse and rainwater harvesting. And you'll hear a little more from Kat, who's chairing the panel later on. Go and chat with Kat, chat with Nathan, chat with George. Come and find me and I'll point you in the right direction if you want to know what they are doing, working with house builders to make sure that we put this into the next generation of houses that we have. There are new products coming to the market, and you're going to hear from Lutz and Sam shortly, and they're going to talk about how to make this a reality, like things like Greywater showers. And actually, I went and made a podcast with Sam and his colleagues a few weeks ago. That's the video that you'll see upstairs. We went to Plymouth Argyle Football Club, which was super cool. Their entire pitch is watered by rainwater. We also visited a community farm that reduced their water bills from thousands of pounds a month, and it's a charity, to nothing, because they just went on to rainwater. And a primary school, which was probably my favourite bit of the visit. They not only stopped flooding in the dell, in the grounds, but all of the pupils now understand that their toilets are flushed by rainwater. And the regulator, the DWI, is making positive noises about understanding how to ensure our regulations enable this shift to happen. So there really is hope at scale and also, hopefully, for my rainwater tank keynotes. So where does this leave us? Rain will continue to fall, heavier and more often. Water scarcity will continue to bite, harder and more frequently. Flooded homes and parched gardens will not wait for us to be ready. So let's stop asking only how do we overcome barriers. Let's start by asking how do we create desire. Let's tell better stories. Let's make solutions easier. Let's take people with us. Because if not now, then who? And if not us, then who? Oh my gosh, I love that I've messed the end up, but you know what I mean. This is the room, right? So I'm going to come and harass loads of you in the break. Thank you for coming. I hope you enjoy what we're going to talk about today. You'll meet some really passionate people if you haven't already. Come and talk to the evangelists and come and work out with us how you can start making a real difference, whichever corner of the ecosystem you're part of. Thank you very much. Without further ado, how could I forget? I was so bothered about messing up. The wonderful Lutz Jonen to talk to you about how rainwater harvesting systems actually can work.
Yeah, mentions me twice already, but then forget kind of like you do a little introduction. Well, thank you. Good afternoon, everyone. Let me just kind of see if I can move this forward here. Is that the clicker? Go the right direction? Yes. Good. Good afternoon, everyone. My name is Lutz Jonen, and probably as the name gives it away, I'm German. I moved over to the UK in 2004, but I worked already 10 years in the sector of rainwater harvesting in Germany. Germany is probably one of the most advanced countries when it comes to rainwater harvesting in Europe, although I have to say Belgium overtook that quite some time ago because now they have already for more than 10 years, mandatory rainwater harvesting in every new build or even refurbishment, where Germany doesn't do that kind of thing. But from the numbers of systems installed, Germany is the leading country. So we're looking at 80,000 systems a year being installed. And I give you a number of the UK just to kind of give you a little comparison. We don't probably hit 5,000. Okay, so we're way behind. Reasons for this? I'll tell you in the break if you want, because of course otherwise I'm running out of time here. What Nikki was describing was really interesting because of course she was mentioning the builder and the plumber and they're all going, oh, that's new, that stuff. Kind of Germany had the same issue, right? So, when started in the 80s, there was no rainwater harvesting either, right? So this whole industry developed nowadays. As I always make that as a little story to everyone. When I go back to Germany and I have a party of friends and people ask me, what do you do? And I say, oh, I run a company that does rainwater harvesting in the UK. Oh, and they go, like rainwater harvesting? Yeah, my uncle has a system and my brother does have a system. It's very natural. If I do that in the UK, people go like, rainwater harvesting? You mean a water butt? I said, yeah, something slightly bigger than that, and I'll show you. So that kind of gives you the perspective of where we are, and I completely agree with Nikki here. We are behind. We got to move this, and the question is how are we moving it. I've been asked to do something on a little bit innovation stuff, which my company, Equality, we specialize in larger commercial systems. So sorry when this is a little bit not kind of house scale systems, but it's still housing in there. And what I brought you is probably in a housing development, a clay farm in Cambridge, which is a very nice one, which is supplying 208 units. I go into details a little later on. Then we have a commercial development, Bloomberg headquarters. If you're in Londoner, you go to the city, sorry. That's one of the buildings right in there. And Bloomberg decided to go very green, especially in the water sector. And then we have a mixed development here, South Bank Place. It's a large development where the Shell Center is. I don't know if you're aware, with 6 residential tower blocks and 2 commercial ones. Again, I'm going to show you a little bit more details on this a little bit later on. Now let's jump right in and look at Clay Farm. So why is Clay Farm an innovative project? Point is here, in 2000 and, So we started designing in 2014. AECOM, a big consultancy company, had the task to look at the housing development. At the time, they were building 2,000 homes in Cambridge. And one part of this had to hit a code level, Code Sustainable Homes. I don't know if anybody's aware of this, but it's a certification that was existing years ago that was pushing building design. They wanted to see water reductions, energy reductions that are going to be in place, and gave you a scoring for this. And the highest score or the highest level of water reuse or water reduction in that was 80 liters. And Clay Farm is a development from Cambridge Council, so they decided to kind of try to hit this high-level code for sustainable homes in that development. And this development they took is in Trumpington, and you can see there's about these little quads. They have about 23, I saw a little bit picture later on, apartment elements in there, and that was aiming for 80 liters. Now, if you're aware of housing, like Nikki mentioned it, 30% you said? Yeah. Saving, right? So the problem is you're having with rainwater harvesting is you have to collect it from somewhere. Yeah, so it depends on where you are. So if you're in the west of the country, you get a lot of rain. If you're in the east country, you get a little rain. And then, of course, it depends on how much roof area you have to collect. When we did the design with AECOM, we looked into the 80 liters they wanted to achieve. And of course, you can achieve certain reductions through low flow devices, but they needed more than that. And we looked at this and said, rainwater harvesting alone is not going to do it because these quads don't have enough roof area in comparison to the people living in it to get to that number, okay? So then we said, okay, what can we do? Why not collect more water? So we started designing a system that collects all of the surface water from this development there. So that means road runoff, pavements, balconies, anything you get, the courtyards, yeah, which of course means the water quality is of course different. Yeah, when you're catching water off a roof, it's fairly clean. If you do that off surface, especially roads, you can have all kinds of nasty stuff in there, right? So therefore, we designed this, what we then call a stormwater harvesting system, because rainwater harvesting we normally define as water from the roof. Stormwater is that water what we're collecting from the surface area. So what was then the strategy to get there? And as you can see here, with attenuation was complete, so the flood management of the whole development was completely designed differently, right? So we had a standalone water reuse system. So what was the system then applied? So we were capturing all of the water, and that went then through a reed bed. You see that in the corner there. In the central part of the development was a nice green, and they put 2 reed beds in there, which literally look like a little nice green feature in the middle of it, but it does treat the water, okay? So when the water flows in it, reed beds are very good of treating water. That water then flows out of the reed bed into an underground tank, 240 cubic meters underground. That water is then lifted into a little treatment room, you can see that on the picture, where we then thought about the water quality, what we're gonna get. We need to probably treat that water further with what we call polishing. Yeah, and that water then is lifted into that black tank, which then distributes the water to the application. So there's toilets in this development and bin stores. And if we're running out of water, that black tank is topped up with mains water, okay? Of course, all supplied via a separate pipework system. Yeah, you need to clearly separate the non-potable from the potable, okay? That's very important. So the point is, we then installed the system with the developer. At the time, we were monitoring the system. Biggest challenge, of course, as I mentioned, was water quality, right, and availability. Okay, but from the design, what we've designed, we should have hit 80 liters per person per day. Achievements: since 2018, the system is running. And it saves about 4,000 to 5,000 cubic meters per year, which is roughly, there you go, 22 to 27 liters per person in that development, although we don't know the numbers of the people in it. We just make an estimation of roughly 2.4 people per apartment. We reduce the flow of the rainwater off the site because literally we don't capture enough to supply everything, right? That's why we're only getting 22 to 27 liters of the water in there. That means all of the rainwater is captured and being resupplied to the toilets, so therefore nothing really hits the sewer system. So from a flood point of view, great. You know, volume-wise, 0, okay? Now, the problem, so this was the approach. Unfortunately, and you know, there's a picture of the water quality we achieve, yeah? So this reed bed is crystal clear water coming through the whole system, yeah? You wouldn't tell if it's mains water or not, okay? So this is where people didn't even know there's a system installed for quite some time until the caretaker of the development kind of told people like, you know, this is a rainwater harvesting system, you're getting water from this supply. But unfortunately, as to the design we were looking for, 80 liters per person per day, we didn't achieve this. Okay, now the question is why? Now point is one, impact the drainage system, so collecting all the water to one point is very important that it doesn't leak, right? So our problem was they had a lot of courtyards which were collecting the water in a little bit of a drainage channel that then led to the reed bed. These drainage channels were leaking. Yeah, so in two or three of these courtyards, you can literally see the gaps. Yeah, so whenever it rains, the water literally infiltrates in the ground and never makes it to the reed bed. So therefore, we're not collecting what we thought we would collect. The other point was that the impact of the reed bed, we completely underestimated what we're getting out of it. The water quality was so good, that's why I set a picture there. Every time I take people to this development and show them the water quality, it's just amazing. Yeah, so the impact of this, that our treatment afterwards we were able to reduce that massively because there was no need. Yeah, so the water quality is already good enough for the purposes we supply it to. The project had a lot of interest because it's currently the only operational communal system. It's a system that supplies multiple homes in one go. You know, at the end, even ITV came along and had a little session on that. But we're bringing people, developers there, government, to see what is possible, right? It's already possible today, and why we're not doing this large scale, okay? That's the question we ask. Next development I wanted to talk about is a commercial building. So Bloomberg headquarter, they came to us and said, listen, guys, we don't want to supply any potable water to the toilets. We are thinking about a black water recycling system. We want to have a sewage treatment works in our building and then take that water and supply it to the toilets. Well, the engineer at the time, and as you see what size of building that is, occupancy 6,700 roughly, you know, in the building with these two the building cores there. So the point was the engineer said, why do you want to do a black water, so a sewage treatment plant in the middle of London, yeah, where there's a sewer system right there where you can drop your sewage in. It's going to be a massive amount of cost to doing this, smell issues, operational, because you have to probably have somebody that runs this every day. Yeah, you have to have a specialist person to do this. Why can we do it a little bit simpler by introducing other elements, right? So the challenges here were the client said, you know, we are high level sustainability, so they did, of course, all the other stuff on energy and the other aspects of the building. Then, of course, the other challenge is offices. The problem of offices, again, you have a high-rise building, you know, that means roof area compared to the amount of people is not very favorable. So from a rainwater harvesting perspective, you're not getting enough. Greywater recycling, by the way, when I talk about this, greywater is normally collected from showers and hand wash basins, okay? So it's a water quality which is, of course, part of sewage, but it's fairly clean. As you can imagine, if you're showering, then the water going down is not really bad, and if you're washing your hands, it's not either. But the amount of water you're creating in an office, where of course hardly anybody showers, right? So the amount of shower water is very little. So hand wash basin water is what you can collect. Again, toilet flushing in comparison to this is massively more. So usually if you have a 4 liter flush, you're flushing something like 4 liters, 3.5 liters away. Think about your hand wash basin. If you do the 20-second one, you might be collecting a little bit more water, but who really does sing the song, right? I mean, the happy birthday song. So it's not happening a lot, right? So you're looking at maybe 10 seconds of usage. So the point is you have only a fraction of water available for the toilets. So therefore, that was the challenge. And then what low flow devices? Because they were struggling about certain toilets that are there, dual flush, I'm not so sure. So they came up with an idea of saying, you know what? We're going to use vacuum toilets. Okay, forget about that double flush element, vacuum toilets. So they're going to be like in trains or in planes. Yeah, there's an element that sucks the water, so the dirt away with only a little bit of water. And here, this system uses 0.7 liter per flush, which is of course massively comparable to, you know, if you're reducing from 3.5 to 4 liters potentially per flush. Okay, and you don't leave it to the operator, right, to press whatever button, okay? So this was the approach to reduce the toilet flushing, which then of course played into our hands because the availability of rainwater and greywater was suddenly matching the toilet flushing demand, right? So suddenly we're saying, oh, we can achieve your complete supply for toilet flushing water with the combination of rainwater and greywater, okay? And there was even a cooling tower blow down recycling system, which they have a cooling tower there that uses water, and they're holding when the water in between gets dropped, it gets held back, treated, and being put back into the cooling tower. And we've allowed even for a little top-up mechanism to bring that back into our treatment system. So that was the idea. So what did they achieve? Bloomberg headquarters achieved the highest level ever achieved in BREEAM, which is the highest. This is a commercial assessment method certification for green buildings. They achieved the highest score ever achieved. The amount of water, as you can see, I give you a couple of numbers, the kind of recycling and reusing energy-wise, so this literally hit every award in the book, okay? LEED standard, it's an American certification that did as well. Unfortunately, you see that here, we only achieved 90% of the toilet flushing. Bloomberg came to us and said, guys, what have you done? Come to site, we'll have a little discussion here. Where's my 100 liters? Oh, the 100%. And then here comes the problem. Estimating people's water usage, all right? Because we looked at the numbers, they monitor everything. The toilets, the showers, they could tell you exactly where water was coming from. And what was happening? They didn't have enough shower water. So we have allowed for a certain amount of shower water being used, X amount of people using the showers, but the people were not showering as much as they thought. Hence, we were missing 10% of the water, right? Or hand wash basin water wasn't even that much either, right? So again, our little 10 seconds, maybe people doing only 5 seconds. So the problem is there that we as designers, we sit in there kind of making these calculations and think about what much water we're getting, and then you come up with like, unfortunately not, okay? And of course you could argue what Nikki was saying about rainwater harvesting. You cannot make it rain, right? So that's the other element that we're having. It's really interesting. Clay Farm, by the way, just to give you a little bit of climate change view, Clay Farm, as I said, was holding back or using 4,000 to 5,000 cubic meters a year, right? Really good. Last year, when there was a very dry spell, we didn't get to that number. We only did about 3,000, 1,000 less, just because it didn't rain as much. And unfortunately, that's of course what we're seeing coming in terms of climate change. Just as a little bit of a side story. So this is where Bloomberg kind of showed us what you can do if you're really trying, yeah? Why not vacuum toilets and certain elements, you know, that are doing a really good job. Nice thing also there is what I'll come at in the next stage is when we talk about cross connections between pipe work. Yeah, that leads me to the third project where I wanted to touch on. This is South Bank Place. Now, this is one of the big housing developments in London. As you can see there, the picture, these are right next to the Thames, very nice apartments been put there around the Shell Tower, which is still a central part of the development. They put up 6 residential towers and 2 commercial ones. The whole development is one plant. I mean, the whole, you know, all the buildings are sharing plant rooms. Yeah? Underneath, there's one big maze, yeah, underneath this complex. That are all these plant rooms. You can literally walk from one to the other. The problem we had, or what we had as challenge here, is of course they wanted to achieve the high coat level, which I mentioned on the Clay Farm one. It's the same story here, because it's that old. That project is from 2000. The design started in 2008-9, yeah, where the coat was still alive, because the coat doesn't exist anymore. High cooling water demand for these commercial towers, the 2 they have. And then, of course, they wanted to design to high-level BREEAM, so they needed water. And as I mentioned to you in Bloomberg, the relationship in commercial towers is not very good. So that's where there was a little bit of a challenge. And then on the residential tower, it was all about future occupancy, because they already knew they're going to sell loads of these apartments abroad, yeah, in Hong Kong or wherever. So they don't even know how many people will be living in these towers, because they might be just an investment. Okay, so therefore we didn't know, how much water the system will really produce or have to supply. So we had to make assumptions of occupancy rates. all that together, was part of the challenges. Now, the strategy was that we were using as much rainwater as we can because they needed 1,000 cubic meter attenuation anyway. And we used or in the design, we used a system that would combine the attenuation, the flood management tanks with rainwater harvesting. Sam is going to touch on this because at the end of the day, SDS supplied that, whether this technology. Greywater recycling in every tower. Now, thinking about residential towers in terms of showering. Have a lot of showering going on in residential, right? A lot of people shower every day, yeah, compared to the office tower. So we had an oversupply of greywater in terms of yield coming from the showers, because if you're simply taking a normal shower, which probably be an 8 liter per minute shower at home, and your average shower time in the UK is 5 minutes, you're creating 40 liters every shower. In toilet flushing, you should not be using more, well, hopefully not more than 20 liters. Okay, so that means you have double the amount of water in one shower than you really need for yourself. So if one person in the house showers, you already have water for 2 people. Okay, so the point is, if there's a certain showering behavior there, you're going to have much more greywater than you really need for the supply of the residential towers. So the design was that we then collect from the residential towers and feed the commercial towers because they don't have enough. Right? So we had a system in there where when the treatment levels would rise to a certain point, the system would free up water that the commercial towers could draw on. Okay? So that was one. The construction as to the element of combining attenuation and rainwater harvesting, we were able to not have to build another 345 cubic meter rainwater harvesting tank separate. Again, I'm not going to touch on it. Sam, you're probably going to cover that. Then, of course, high-quality greywater, as you can see there on the picture. The left-hand side is the greywater you're getting into the tank, but on the right-hand side, you see what you're getting out of there. Crystal clear water. Again, you wouldn't know if that is potable water or not, okay? So these are the achievements we did, but lessons learned, design for future occupancy. So what we now realize, we don't have enough people living in these residential blocks to even create enough water to push it to the commercial towers. Yeah, there are just not enough people. 50% of those apartments are not even occupied. I mean, we talk to the local, the concierge people and say, like, we have certain keys hanging here that nobody even been picked up, right? So this is an element of problems in those kind of developments. And then cross connection, we suddenly found out that on the collection side, people had done amendments to their apartment and cross-connected their toilet into the greywater pipe, because that's collected separately, right? So the greywater is collected via, from the showers and hand wash basin separately in a pipe, going into the system, and then we supply it via a separate pipe to the toilets. So two buildings have a cross-connection, so coming into the system, and of course the system is not built to treat sewage, it's built to treat greywater, hence you cannot treat the water, the system is off. We need to find where somebody did that cross-connection. Lessons learned is, because to all regulations, you have to identify the supply side, that you clearly separate out the non-potable from the potable. That needs to be clearly marked and labeled that you don't make a cross-connection on the distribution side. That's already up in the standards. But on the collection side, nobody said so. So, of course, it's very easy then to potentially plumb into the wrong elements of it. And then the whole system was supposed to be monitored and, supplying a lot of information. Unfortunately, basement if you go into basements in London, you're looking at a lot of concrete, and it's very difficult to get a signal out of this. And funny enough, we mentioned it to the developer and said, hey, we have all these controls in there. We can monitor for you everything you want. And they said, we're not interested. Right? So we literally supplied the hardware on the wall, and they would not give us a connection to a system that goes, gets a signal to our platform. We weren't interested, although it was all designed in, was all delivered, never got commissioned, right? Just no interest. And this is where it comes back to Nikki. There is no driver for making these systems work. We always said, guys, sort out your cross-connection. We get the system back up and running. We'd save a lot of water. And they couldn't care less. Right? This is where there is nobody kind of saying, like, you have to keep the system running or you get a penalty. Like in the US or in Australia, there's schemes out that if you're going to planning and you say this building is going to use X amount of water, because you have those systems in place and you use more water, you get a penalty for this. You got to pay more, because you're not achieving what you were supposed to achieve. Things like that kind of drive people to kind of make this work as it should. So this is where that just gives you an idea, but it shows you at the same time what is possible, right? If we solve these little problems there, which is purely design and installation related, you can get systems that are very effective. The amount of water saved in this one, we were designing it to literally save all of the toilet flushing water in the development, right? Which was quite a bit, as you can imagine, the number of occupancy in this development. I would have to look up what it is, but it's quite a lot. That brings me to the end of my little presentation, a nice little handover to Sam. He's the water reuse manager at SDS. Not going to say more, you can introduce yourself, and thank you very much for your attention. If you need anything, I'm back in the break.
Thank you, Lutz. Good afternoon, everyone. Yeah, so I'm Sam. I am the water reuse manager for SDS, as Lutz said. And I'm going to, obviously the questions will come later on from Lutz's slides. I'm just going to give you a quick whistle-stop tour to begin with of SDS, who we are and what we do, just so that the case studies that come towards the end make a little bit more sense in terms of what we've provided with them. So SDS have been around now for over 20 years. We're a leading provider of SUDs within the UK, sustainable urban drainage systems. And our sort of whole ethos is around design, manufacture, supply and install. So these are sort of some of the product families that SDS have developed over the years and sort of bought in-house. Obviously, the flood prevention side, the SUD systems is where we started off and where our sort of core business still is. Then we've bolted onto that with water quality aspects, with water reuse and with the smart monitoring systems, some of which obviously you've heard some about from Lutz already. But just to give you a bit of a whistle-stop tour then about our key products and where they'll come into the case study. So Geolite is our core attenuation product as a geocellular attenuation device. High void capacity as what we call a closed system in terms of having a perforated distribution pipe which keeps silt and everything out of the crate systems to make them easy to maintain. And these are scalable, so these can be small-scale soakaways, attenuation systems on plot developments, and they can go right up to some of our big case studies on our website, such as Bishop Stortford or Lossiemouth, which is a slightly different product, but again, just gives you an idea of the scale, which we'll have a photo of shortly. So that is Geolite. Then we have our Whale-like system. So this is a large diameter HDPE pipe systems, which we can manufacture straight runs of pipe, we can manufacture into multi-leg tanks, but we can also manufacture into manholes, pump chambers, water treatment devices, which I'll come on to. And we can manufacture this up to 3.5 meters in diameter. So we can do anything, any scale of system. And we also have this system adopted by multiple water companies and by Highways UK. The treatment devices we can manufacture out of that Whale-like system. The Aquaswell we'll hear a bit more about later on, but this is a hydrodynamic vortex separator looking at taking out hydrocarbons from water runoff, surface water runoff. And the Aquafilter, which is more for heavy metals, sort of highway applications, large-scale applications, looking at offering mitigation indices for developments for their surface water runoff. These sort of systems as well, the Aquaswell we've actually used on a number of sites as sort of a pre-filter for rainwater harvesting systems where we do combined systems. And the whole premise of these is to sort of treat water upstream of the attenuation rather than downstream before discharge. So this limits the sort of contamination that's arriving at the attenuation tanks and meaning we don't have to remove it just before we discharge into the environment or a watercourse. AquaExchange is the other water quality treatment product we have, which is a filtration media. So we can use this within filter strips, we can use it within the aquafilters, and we can also use it sort of similarly to the reed bed on Clay Farms system. This looks at capturing and holding on to contaminants within water runoff and allowing us to have a cleaner solution, sort of a treatment train, maybe used in conjunction with an Aquaswell or an aquafilter to have cleaner water arriving into our storage tanks or our reuse systems. Water reuse, which is obviously my sort of area of expertise within SDS. So obviously you've heard a little bit about Greywater from Lutz already, an image of the sort of on-demand treatment system that SDS use at the moment within predominantly the London marketplace, but across the UK and abroad. So this is looking at that capture of showers, wash hand basin discharge, and then treating that for non-potable use. This system is an on-demand system, so we use a chemical dosing, which means that we're a little bit less susceptible to low occupancy buildings, and means we can commission systems, but we also still rely on that flow to get that treatment through systems as well. So the occupancy issue that Lutz touched upon still does have an issue, but not quite as much for us with the on-demand system. So rainwater harvesting, obviously, the little diagram there of sort of the flow systems and a couple of systems that are on the market, obviously plot-based systems, as well as sort of commercial grade systems with standalone tanks, storage predominantly underground on new developments, but also available for above ground storage as well. So looking at that collection, filtration, storage and distribution, as Nikki mentioned, your system probably looks something like the one in the bottom left-hand corner.
Yeah, but mine doesn't work.
There's no flashing red lights on that one, no.
Very small.
And then sort of the product that is our sort of flagship in terms of the water reuse system is that IntelliStorm system. So Lutz mentioned it there with South Bank, which we'll come on to as a case study, but that combining of attenuation storage and rainwater harvesting storage into one tank or storage vessel, storage device, which allows us to dual purpose that storage and not have a secondary tank or rely on that. This allows us to capture that water in higher volumes rather than allowing overflow from a traditional rainwater harvesting system, and allowing us to capture that and use it on site when it comes and when it falls in those high intensities. As we're seeing that change in patterns of rainfall data, we are seeing more intense rainfall in short periods of time rather than that sort of trickle over a period of time. So this allows us to do that. We have these systems. This is a scalable system as well. Obviously, Nikki mentioned the podcast that's been done with herself. So we've used this on 200-litre water butts up to the big tanks we've got at South Bank Place. So this is a scalable system. It's scalable technology. It's in-house and it's customisable for us, which is brilliant. It means it's adaptable and we can use it for different applications, monitor it. And then we can also make it future-proof. So we can go back to these systems, we can adapt them, we can change the parameters within them, we can adapt to changing rainfall data, we can adapt to those sort of climate change effects. Some remotely, depending on, obviously, as Lutz said, what the client allows us to access on site and take off site. And we use an agnostic SIM card system in these, so we don't touch Wi-Fi systems, we don't touch building management systems with these. They have their own SIM cards which can access any network, and that allows us to sort of be separate from building systems themselves, provided we can get signal. I look at George because we had a conversation earlier. But again, basements do cause us a bit of an issue. So there are some long runs with antennas and things like that that we need to consider when implementing systems like this. I've touched on some of these already, but this little diagram on the right-hand side gives you an idea about how potentially this could be used, regulations allowing, on sort of multi-occupancy development. So this is similar to sort of the Clay Farm case study that Lutz touched on, with a centralised storage system distributing through a non-potable infrastructure to each of the individual plots. Again, you've heard a little bit of this already, but in terms of reducing the peak loads on sewers and the CSO flows that Nikki mentioned earlier, what this allows us to do is essentially, if we need to release water from a site, we can do it in advance of that rainfall landing on site, which means that essentially the site becomes offline during that rainfall period. So we can actually accommodate that rainfall on site and not touch the downstream network, which obviously for something like London with ageing infrastructure is really important. Symbiotic monitoring, just briefly to touch on this as well. So this works predominantly alongside our IntelliStorm system, but also can be standalone. So this is what allows us to do that data harvesting, allows us to remote access systems to give feedback and give you some of the data out of the system to tell you what it's using, how it's reacting, and allows us to tweak it as well and do preventative maintenance and things like that. Just quickly, before we go into the case studies, to give you sort of an idea of what's to come, integrated water management really is a focus for SDS. You know, we have this wide range of products and this portfolio of products and that design, manufacture, install, maintain ethos. And being able to combine that with systems is really important. You know, gone are the days where sites now just have a big tank underground. You know, they need to have green infrastructure. They need to be able to show biodiversity net gain. So being able to use our systems in conjunction with green infrastructure, so to have some storage above ground or to have a tank below a reed bed, for example, as you've heard already, allows us to meet those criteria for designers, for end users and for clients. And it's really beneficial. You know, we've seen a lot of good results from the projects, some of which we'll come on to shortly. So with that in mind, we mentioned about sort of what the future could look like earlier on, and some people have touched on it, and Nikki obviously had that call to action earlier on. But this infographic here gives you an idea of what a system could potentially look like on a large-scale housing development in the future, and this is something that enabling what small to smart communities have really dug into and done a lot of research on. So I do, if you haven't read their sort of output already, please go and do so, because we as a member of the UKWRA, which Lutz chairs up, we're really pushing for this because we think this is the future. Yeah, having a large-scale storage for surface water runoff on a site, whether that be combined with above-ground storage and below-ground storage, using something like the Aquaswell shown in the bottom corner as that filtration device. So if water leaves site, it's leaving clean. And if we can reuse it on site for non-potable infrastructure, then we do so. We harvest it into a centralised plant room, add any polishing or treatment to it, and distribute it through its own water network. Obviously, things do need to change, as we've heard, to allow this. You know, we need to be able to have a system where those systems and the pipework can be adopted. They can be labelled correctly. People are trained to be able to service these systems so that you're not reliant on a specialist call-out for £500. These are all things that need to develop, but this is what the future could look like. This could make developments climate resilient. So a few case studies. I focused on some of the ones upstairs and some of the more bigger infrastructure ones, but obviously some of these products are also agnostic across smaller scale systems. As Nikki mentioned, you know, we have the Plymouth Argyle systems, we have systems such as the farms and the schools. So please do reach out to myself or watch Nikki's podcast or listen to Nikki's podcast, because they're all spoken about on there as well. But just some of the case studies we've got here in London and upstairs. So Holland Park, I know this is Duke's Lodge, the old name, but again, luxury high-end apartments, limited plant space, that question mark over occupancy again that Lutz mentioned earlier on. So here we actually designed a system to fit into a really small plant space, to use an on-demand treatment system so it could be adaptable to that occupancy challenge. We could commission the system when it needed to be commissioned, and it could be isolated if that occupancy didn't come. But this allowed us to provide the non-potable water for toilet flushing and to reduce the reliance on mains water infrastructure. So you can see there at the bottom some stats in terms of 2.1 cubic metres per day and 85.8% efficiency in terms of the system. And the system is still operating today. Yeah, it's working well, it gets maintained well, it has preventative maintenance alongside our monitoring system. And this is a sort of example of how systems are not limited to these large-scale developments. You know, this is only 25 high-end residencies. This isn't an office block with flats above it. This is a smaller development, but still can make use of the same sort of infrastructure systems where they can make a big difference on the mains water reliance of the building. Obviously, we've heard about this one already. So, as Lutz mentioned, we did the sort of harvesting attenuation combined system on this with IntelliStorm. So we've got the big attenuation tanks in this shared basement. They're concrete tanks that are part of the structure. And you can see the image there in the bottom right of the discharge tank, pump, on the left-hand side, and then the small transfer pump on the right-hand side to make water available back into the building. This system was designed to supply water, I believe originally again, Lutz mentioned this was designed a long time ago now, but originally for the cooling towers, to which the supply of the cooling towers was not overly open to. So we're actually looking at different ways so we can use the system to assist with Lutz's Greywater system, potentially top that up. Obviously, he's not getting the yield he expects, as he mentioned. So if we can top that up with rainwater, which is falling from the sky, then even better for the development itself. Again, over 1,000 cubic metres of storage available rather than having that separate 345 cube rainwater harvesting tank, so saving space within the basement where space is limited even on a development of this size. And actually, when if the system's fully operational, the discharge pumps are going to operate in a very small window. You know, if this system was a standalone attenuation system, every time there was a level of water in the tank, the big pumps would run, discharge water into the Thames Water network. Whereas with IntelliStorm now, what we can do is, if we've got the capacity to store that water on site, we don't have to run those big pumps. We can hold those off, and we can just action the small pump if we can use that water in the building. So we're actually limiting the amount of time we're running these pumps by using the storages on site. Attenuation is designed to 1 in 100 years plus 40% for climate change. As the clue's in the name, that doesn't happen very often, or it shouldn't happen very often. So what's this storage doing the rest of the time? You know, if you have development and you have to put in 100 cube or 1,000 cube of attenuation, how often is that tank full? If we can use something like IntelliStorm or a smart rainwater harvesting system to actually close that discharge of that tank, hold on to that water, use our infrastructure and your storage that you've already paid for, rather than relying on the aging networks to store that water downstream, we can take systems offline, as I mentioned. We can then harvest that water and reuse it, rather than relying on the mains water. The last project I'll mention, which is sort of why I gave you the whistle-stop tour, because we used virtually every single one of them, is Babraham Research Campus in Cambridge. Now, this project, again, more on the commercial side, but here you've got a site that had attenuation tanks. It wanted to do harvesting. It wanted to be sustainable, but it needed a system to enable it to do that. So here we used aquaswells as pre-filters to the attenuation tank. We used geolite storage tanks to store the water on site to meet the attenuation requirement for that site. We then used our whale-like harvesting chambers. So we had a chamber at the discharge point where we installed a valve where we could allow water to leave the tank before rainfall happened, or we could close that valve and hold on to the water in the tank. We used an additional chamber then to pump that water back into the building, and we had a brake tank, polishing system, and booster pump set to distribute that water around the building to flush the toilets and be used for non-potable usage. By doing this, it freed up space because it allowed, whereas the original design that we were consulted on had a harvesting tank down below the geolite storage volume, the attenuation storage volume, we were able to shallow that dig out, use the storage that was already being purchased for the site for attenuation, and it freed up the ability for this site to then go after the other goals for sustainability and for biodiversity net gain and its nature goals. Obviously, being in Cambridge, it's in a water-stressed area anyway, so this is really important for them. The system is still managed by them on site. We assist them with servicing, and we've got our IntelliStorm and symbiotic monitoring system, so we can actually see that system and we can offer preventative maintenance when we see drop-offs in performance of pumps and things like that. So actually being able to combine all of the systems into one system in its entirety allowed us to do that for the client and to offer that assistance from a design perspective all the way through manufacture, installation, and now to servicing. I'll come back to this infographic just to finish off with the question mark within the title of the slide, but there's this infographic for me, well, obviously working for STS and working in the industry, is interesting purely because all of this technology, all of these devices, all of these products are available. They can be put into play now, as we've seen with Clay Farm from Lutz, as we've seen with South Bank, with Babraham, with Holland Park. You know, this is all possible, but also not possible at the same time. So those things that need to change within legislation, those things that need to change within attitudes, within public awareness, all the things that enabling water smart communities are shouting about are really important. And as Nikki mentioned earlier on, we're very good at reacting when people want something. This is available, we can do this. You know, STS has a sister company in Albion Water as a NAV who would be willing to adopt systems like this, providing that we can get the license to provide them, but they're not allowed to. These are the things that need to change. And as Nikki mentioned, you know, plot-based systems are all well and good, but these are the systems that can offer us the real change with the operation, with the maintenance, with the servicing. So please do go and do that research, have a look at enabling water smart communities. I believe me and Lutz are going to take some questions. Thank you very much.
Hi Sam, hi Lutz, thanks for the presentation. I'm Laura from Good Homes Alliance. My question's to you, Lutz, and it's actually putting a question back to you. You asked the developers and the policymakers that you took around Clay Farm, why wasn't this happening at scale? What was their answer?
Well, one is the element that Sam was mentioning, right? The legislation doesn't allow this at the moment. The problem for a developer, normally he wants to build the houses and walk away afterwards, right? So who's going to operate the system? Who are the stakeholders that take responsibility for running it? Luckily at Clay Farm, it's the estate, so Cambridge Council owns the estate. Therefore, they have an estate management company, so it's all in one hand, right? The minute you do this on normal developments, which then the house builder builds X amount of 100 houses, they get sold off one by one, and there's an infrastructure that needs to be maintained and managed, right? And currently, this adoption that Sam was referring to is currently not allowed, right? So therefore, there's, the developers are holding back because, they don't want to manage it. They don't want to do it, right? So they want to hand it over to somebody else to then manage it, and therefore we don't see any of this. That's probably the answer, Sam.
Yeah, I think you summed it up quite well, yeah.
Thank you. Very interesting case studies. Many of them seem to have come from clients who wanted to prove a point. The projects, are they actually economic? Are you delivering a saving that can be sold as part of the development of demand that Nikki was talking about? Or do we have to continue with clients who want to say they're doing the right thing for the planet?
Yeah, I mean, from our perspective, obviously, a lot of the time, the person who's designing the building and building the building isn't necessarily the one paying the water bill. So the drivers there, especially within London, in terms of building sustainable buildings and having these achievements and buildings winning a load of awards, which is brilliant. But obviously, it's the operator and the owner of that building who feels the benefit of their water bill. I mean, from our perspective, we still maintain a lot of these systems. We're still involved with the facilities management, and I don't think a lot of them would bother to keep them online from experience in the past. Obviously, I've only been in the industry for 7 or 8 years, but sort of from what I've heard from before that and what I know from before that is a lot of systems become redundant and become left alone because people don't see the benefit. Now, obviously, what the systems like the monitoring systems that Lutz has got on Clay Farm and that we've got with our symbiotic systems, what that allows us to do is actually present that data and harvest that data from sites now, so people are starting to see what we can do. Some of the projects that Neil's done, Neil, our Director of Technology Services within SDS, he's done a lot of research in terms of that CSO overflow. So, part of the value of those projects is actually getting the data out and seeing that. And now we're starting to see that within reuse projects. And I think once that message gets across, and all that data is being fed into the work that the guys at Enabling Water Smart Communities are doing, and actually that public perception is a big point, because the more we can get that message out there and we can show the evidence, Nikki is evidence-based with everything she does. She needs that evidence. People like Nikki, like George, like Nathan, the guys from these projects need that evidence to be able to push that message. But I think we can still do more as an industry to get that out there. But again, there is that join up between the people involved in the projects at the early stage and the designers, and then the guys actually operating and building and living in and operating these buildings at the end.
But coming to the point of economics, right? Putting a system in, like Nikki said, currently, no, right? It doesn't pay off, right? Because water prices are not reflecting how much water we have, right? The water prices don't tell you that we have a water issue. So therefore, water is kept cheap, and therefore the return is, of course, very little. If you go in the UK from east to west, the water prices are rising. In the west, water prices are down to £5 to £6 a cubic meter. London had the lowest water prices. Well, I mean, now they raised them slightly, but in the most water scarce area, right? London is part of the water stressed area. Water is cheaper than in areas where you don't have water stress. Doesn't make sense. So there's a fundamental economic issue here that what is scarce is not expensive. Okay, and this is where currently the economics don't work. But if we would be keeping on going like this, we're just going to simply run out of water. And that's why I said what we're trying to get across to the developers, that building houses where they're going like, why would I put more in than I need to? Well, if you want to keep on building houses, you need water to operate them, right? If we're running out of water, you're not going to be building houses either, right? It's going to be an interesting one with Andrew.
Yeah, that's for you. If he mentions litres per person per day, I'm leaving.
Okay.
I'm being recorded, aren't I? Yeah, righto. We're about a month, sorry, Andrew Tucker from Thames Water. We're about a month away from Ofwat's Water Efficiency Lab. So it's a funding pot for various research projects. One of those projects that's in the mix is the 50 litre home initiative, which is going to be looking at getting next generation or absolute best in class, everything in the kitchen, everything in the bathroom, with the products, with the tech, put it in one place and test it to within an inch of its life to see before and after. How far can domestic consumption go down? But reuse is a bit of a question mark at the moment in that equation. If you've got a project that's going to put, say for instance, 50 existing homes, complete refurb, 50 new homes, what reuse kit would you put forward to be tested? Wish list.
Are these plot homes or is this high rise?
You choose. Go for it.
It comes back to Lutz's point a little bit earlier on in terms of that roof area versus demand, because obviously if it is a high-rise development with less roof area than we have with 50 individual plots. So the natural answer, I think, to begin with would be rainwater harvesting systems. Obviously, the perfect world would be to have a communal-based system that can harvest the surface water. Obviously, unlikely to do that within that time frame. So initially, it would have to be plot-based rainwater harvesting. They're probably, as Nicky's experienced, they're not perfect systems. You know, there are systems out there. You can go and buy one from B&Q if you really want to. I'm sure you can. But plot-based, at the moment, it would have to be plot-based harvesting, purely because that's the technology that would give you the best yield versus demand and would be operational within a remit at the moment within the legislation.
No property-based Greywater take that we should.
Oh, yeah.
There is, yeah. Obviously, the systems we deal with from an SS perspective are more commercial based. So there are systems on the market. There may even be people in the room. Yeah, there she is. And so, yeah, from our perspective as a company, it would be harvesting because that's what we do. And our smallest Greywater system wouldn't be efficient in that application.
Okay.
Yeah. The back there, I think, was first. If we have time for one more.
Thank you. The last speaker, last slide. Is there an equivalent for retrofit of that diagram?
Good question. In theory, you could do the same thing. It's just a lot more expensive. It's getting the pipe work infrastructure in is the costly bit. Enabling Water Smart Communities done a really good piece of work on the costing out of those sort of communal versus plot-based systems. Putting that infrastructure in is the expensive bit. And doing that retrospectively is going to cost you way more money. And as we just touched on, the economies of scale probably don't make it commercially viable to do that. But that's not to say that, again, at the moment, the legislation doesn't allow it. So the infrastructure and the legislation isn't in place to give you the framework to even work towards to do that. Obviously, if that becomes a thing within new developments, then that opens the door to potential retrofit and for developments in that technology over time.
And we as the association are trying to get the government to kind of bring a dual pipework system in all new buildings, in the building regulations, because the point is if we are building from the start the dual pipework in your building, you will be able to retrofit later on. Currently, our buildings are not future-proofed. In the US, San Francisco already has that scheme on, so they have, you have to plumb already without even installing a system, you have to have that dual pipework system.
Two more.
Who was next, I think?
Thank you. Chris Rogers from RPS. Water companies traditionally charge an amount of water sent into a property. I see this as a disruptor to the market because you're not necessarily bringing in water from the water company, but you're still sending out very heavily polluted water to be treated by them. Do you see that as an issue, or are the water companies seeing that as an issue?
Germany had exactly that question, and there's two ways to it. Second water meter, right, to kind of register how much water goes down the drain. But most companies walked away from this to rather subsidize. They're saying that's our subsidy to kind of get systems in place. They didn't want to block it, so therefore they didn't insist. But there was, at the beginning, there was a call for second water meter, right, to then make sure that you're covering this. But I mean, there's a lot of things to talk about this because there's other elements of metering, which in Germany has completely changed as well, because there's some other issues with general, that one water meter. I mean, I'm going to talk because it takes an hour. Okay.
Yeah, I mean, just to touch on, to expand that a little bit, obviously, Chris, I know you're aware of Albion and sort of their activities. We've got a couple of sites where we have 2 meters on systems, even though it's not being used for non-potable. We've got that data which is being shared with a project in the room. But obviously, we've also got water companies who are offering incentives for developers and for homeowners to put in recycling systems, reuse systems, because ultimately the demand's going to outstrip what can be supplied eventually. So there's a balancing act. Obviously, again, the legislation isn't there to allow any form of adoption at the moment. Is there a mechanism where non-potable water can be charged but at a reduced rate? All of these things are possibilities, but it comes back to that sort of metering structure and what that looks like and putting that in place through the right mechanisms, through legislation and things like that.
One more.
There's one there and one there.
Hi there, I'm Patrick. I was the actual building inspector at South Bank Place. And our dilemma there was that how much pressure could we put on the underground train tracks that was going underneath there. So your issue was there, can you house the reuse water outside of the building? And you couldn't. So then increasingly, in answering the question that was from down there, the industry does need to prove that we can engineer these things outside of the building, and effectively, you know, there is an element of trying to prove that, you know, these things can be done.
Yeah, and as you know from that site, you know, you've got the tanks are effectively structural parts of the building. You know, they're concrete parts of the actual structure of the building. So using that to house water is a good idea. Lots of you will know in London, obviously, the Tottenham Hotspur Stadium, I think they actually use the pillars that hold the stadium up. The void within that is used to store water. So it's having creative ways of using what's already there to actually be able to store infrastructure and to be able to cope with the weight of the water and things like that. I think that's all we've got time for.
Investing needed. Well, we know this country is facing a water scarcity gap, and that gap is not going to be fixed by big new supply schemes, big reservoirs and things in the short term. Those big water supply schemes are going to take 10 to 15 years to come online. So we have got a real water shortage even before those schemes come online. And the gap isn't going to be met by water efficiency measures entirely. So things like water efficient showers, washing machines, those kind of things, that's not going to fix that water scarcity gap entirely. And neither is, I'm afraid, things like behaviour change. It's just not going to meet the gap that we're facing. So we need something more fundamental. And that's where rainwater harvesting and water reuse comes in. And that's why it's so important that we're here today learning about it. There are also other really important benefits that come with rainwater harvesting and water reuse systems. Other benefits from having a more distributed system of water. It's less energy intensive than big water supply systems. Water is really heavy, really heavy. So pumping water around from centralised large water supply schemes is going to take a huge amount of energy. We've also heard today that these systems keep rainwater out of sewers, and that's a great benefit as well. And where we're integrating nature into rainwater capture, so using nature-based solutions to absorb, filter and store rainfall, there are also great benefits for placemaking and for wildlife as well. So we've heard from Lutz, from Sam, and to some extent Nikki as well, that it is kind of possible, this stuff. We've got the technology. We've seen all those lovely diagrams, those great examples. We can do this, but it's difficult. It's not the norm. It's really not mainstream yet. We've heard about the issue of economics. We've heard about legislation, regulatory challenges, and we'll go into that in a bit more detail. We've also heard that the water resources planning system and the supply chains aren't really set up for this yet. So in water companies, clean water and dirty water is treated as separate entities. And yes, we don't have the supply chain really for these kind of distributed small-scale approaches. And the onus seems to lie on house builders and house owners to install and pay for these systems, yet the benefits are felt across society. And then there's the big question of who operates, owns, and maintains these systems. And I keep thinking of Nikki and her £500 that she's going to have to pay to get someone out, even just to look at something. We should do. So my panelists this afternoon are going to help navigate these issues, and I'm going to introduce them properly as they come up. But in brief, we've got Lorna, we've got George, we've got Adrian, and we've got Sarah. And they are all people that have been trying to embed these systems into our homes, into our built environment. So they're going to share insights on design, on maintenance, on installation costs, on working in partnership, regulations and policy. And they're going to give some more examples of where it's working. And together, I really hope we'll be able to draw out the lessons from their experience and identify what is really needed to meaningfully upscale this stuff in all new developments and across our built environment. And it comes back to Nikki's question, really. How do we make this easy for people? How do we create that demand so it happens everywhere? So I'm going to invite my first panelist, Lorna, up to speak first. So Lorna Devenish is a partnership manager at the University of Exeter's Centre for Water Systems, which is supporting world-leading researchers to build collaboration and deliver practical, impactful research. She is also a rainwater reuse champion for WaterWise, which is the UK's leading independent voice on water efficiency. And Lorna previously helped to develop smart rainwater management systems with OTA analytics and also SDS infrastructure, who we've heard from today. And before that, she spent 11 years leading strategic communications and public engagement at South West Water. And Lorna's going to speak about cross-sector collaboration. Thank you.
Thank you, Kat.
I think I'll go that way to avoid
the cables.
wires.
If I do that. Yes. Good afternoon, everyone. This is me. This is a shameless use of my son to promote tap water. I think you'll agree it's very cute. I joined the water industry probably 20 years ago. Actually, he's 16 now, so that gives you an idea of how long. So I've worked at water companies for a water startup, for an established water-related private company, and now I work at the University of Exeter's Centre for Water Systems. So. And they really are a kind of engine room of water research. Just to run you through these pictures, the first one's taken at Wimbleball Reservoir with a South West Water water bottle. This one is taken in London, where we were installing community rainwater systems for community gardens. I do believe that the metal tap was stolen from that tank within about 24 hours of it being put on. The third picture is a very lovely, intelligent water butt that I installed along with my then colleagues at SDS in Deal in Kent, where we were installing a number of smart water butts to keep water out of the drainage system and prevent flooding downstream. And there I am at the end working on a project which is actually a flood and coastal resilience innovation programme project in Letchworth, looking at a rain gauge and telemetry station. So I've worked in several partnership projects, and I don't want to lie to you, partnership can be hard. And I've worked on, so Resilient Together and Blue Heart, they're both part of this innovation programme. AIoT is an Ofwat project. Upstream Thinking was one of the early partnerships within the water company that I worked at South West Water, where they brought together a lot of NGOs to look collectively at catchment management and farming practice. you can get people working at different timescales with different priorities and interests. There can be unclear communication or end goals and different ways of working. So I think everyone who works in a partnership will find that there can be very challenging times. However, I would like to say that there are many great advantages to partnerships of water companies and consultancies and universities and probably local government. Put these people in a room together and magic can happen. And part of that magic, I think, is the academic collaboration. I'd like to spend 5 minutes just to give you a little plug of why it's worthwhile having university on board your project. Partly because we're independent, we're able to publish results transparently, we're trained to construct replicable experiments, and we're not constrained in the questions that we can ask. The writing that a university academic will produce for you is precise and neutral, and they generally have the skills, people skills, to process data and interpret those results. Now, in my centre in particular, you have people who've worked right across the water industry, and so they also understand industry constraints, and they have an appreciation of practical issues, and they're able to inquire deeply into niche subjects. And this picture here is my boss, Pete Melville-Shreve, who is making a lifetime career out of inquiring into a niche subject, I think we'll agree. So, for example, one area of interest in our team is real-time control units. These are units which can be put on an outlet of a tank or a pond, and then controlled remotely based on, a bit like the IntelliStorm system really, based on the weather forecast. So you can pre-release water, and you can close a tank and enable it to hold in water. It's one of the things we discovered about a leading real-time control unit. We got hold of one, we put it in the lab, we threw some tests at it, and we discovered that this particular device leaked at the sides. And it was a device that had been designed for sewers, actually. And we wanted to use it on stormwater tanks. And so this leak was kind of small but significant when you wanted to hold back all the water. But what it did was it gave us data that we could then factor into the calculations for how that unit would behave in real-world conditions. And that then shifted the priorities of where it could best be deployed. So we're asking some of those nitty-gritty questions, and we're doing so fearlessly. So in great collaborations, academics find out industry's needs and see if they can solve the question. Again, here's Pete spamming everyone on LinkedIn, asking the questions that no one else dare ask. But this is a great way to find out what our industry needs, what needs to happen to regulation. How can we make Great Suds the norm, for example? So at our campus in Exeter, which is not currently underwater, because it's on a hill, unlike my front garden, which is underwater, after 3 storms in a row and a very big dump of rain. On our Exeter campus, we're aiming to make this into a living lab. We've got sensors on attenuation tanks. We've got well over 100 vacuum toilets, propyl toilets, which are monitored. We have green roofs, we have rainwater harvesting, and we're planning to do a lot more as well. We're hoping to establish a Water Net Zero campus, so that we can be an industry-leading living lab exemplar, so that everyone can come and have a look at the technology that they're interested in, talk to academics, find out what tests we've done, what data we've grabbed, what we've learned from that. That's our kind of goal, our 10-year vision. We've made a start, and we're starting to sort of pull in some of the literally hundreds of researchers from across many different disciplines to start to tell us what their research is and where that might lead them. But I mean, we in the Centre for Water Systems focus on hydroinformatics and modelling particularly. But there are also economists and social science experts, and there are people looking at the biodiversity, the microbiology. That we have people looking at the whole systems thinking piece in the Global Systems Institute. So we have, I think we have many skills across the university that we would like to harness, in summary. So really that just brings me to my final slide, which is that water is vital, and we need to work together to make sure we all have enough, that we humans aren't wasting it, that we have water when we need it, and that we can prevent or reduce flooding in an increasingly extreme climate. Thank you very much.
Thanks, Lorna. So next up we have George Warren from Anglian Water. So George is the Integrated Water Manager at Anglian Water, and he looks to bring together water resources, wastewater and environmental planning to identify more holistic water management opportunities across the Anglian region. He's responsible for the creation of the Enabling Water Smart Communities programme, and looks to identify and address, that programme looks to identify and address the barriers to integrated water management within new residential development. George is an environmental engineer with almost 20 years of sustainable water management experience, and he's worked within consultancy both in the UK and in Australia with local government, and now within a water company. And I should say that George is also a multi-award winner for his work on SUDS. I can tell you more about that. So George, I think, is going to talk about the Enabling Water Smart Communities project, and particularly how that project is overcoming some of the barriers to water reuse. Right away.
Oh, that's cringe, isn't it, listening to that? Whoa. Thanks, Kat. Right, water reuse. Hopefully you're in the right place. So, as Kat says, George Warren, that's my day job, Integrated Water Manager, although I'm still heavily involved in Enabling Water Smart Communities, which is an Ofwat innovation project, which we started 3.5 years ago now, which brings together a number of organisations. So it's led by Anglian Water, but with Thames Water, United Utilities, CIWEM, Arup as our principal delivery partner, and a whole heap of others, including Good Homes Alliance and the likes. But I'm not necessarily going to talk about that straight away. So I'm going to go through the main barriers. So when we started out, people told us the main barriers to reuse included costs, public perception. People don't like it. They don't want it, apparently. And then the ownership and adoption models. And I'm going to go through some of the evidence that we've created to hopefully address some of these. And I'm very mindful of people taking photos of slides. I'm like, shall I move on? Or? Yeah. I've got to move on. Right. So, from a cost perspective, we looked around the globe trying to find out how much does reuse cost to incorporate. Now, there was a question earlier around retrofit. This programme that we're looking at is very much trying to hit the new build side of things. Very mindful of that retrofit is we need to tackle that too. But just to understand, let's make sure that every building that we're putting in now is actually incorporating the right stuff. So we set about looking at the cost of both community surface water harvesting. So you may recall Lutz referred to this. So this is not just off roofs, but this also includes the hard surfaces as well. We looked at then on-plot, so i.e. just rainwater harvesting within each individual building. And we did the same from a greywater perspective. So looking at multiple buildings, all their grey water coming together, but collected, treated, and then distributed back, and just on plot. We took 12 development sites. We took 9 different housing typologies and went about trying to cost these all up. Here are the kind of the headline results, I guess. So community surface water harvesting averages out around £2,000 per property. That's the additional cost associated with it. I should say that gets to about 2,000 at the point of which there's about 100 homes. It's more expensive for less homes, but it pretty much stays at around £2,000, even if you go up to sort of 300 homes or more. So that is a more cost-efficient way of delivering rainwater harvesting or surface water harvesting than on plot. But when you get to greywater recycling, actually on plot seems to be a bit cheaper than if you were doing community. Now, the reason for that is quite simple. There's a lot of pipe work involved in community greywater recycling if you're trying to collect all that water, take it to a single place, treat it to then pump it back again. Now, it does start to get cheaper for those dense developments and the sort of ones that I guess Sam and Lutz were talking about as well, where you've got high-rise tower blocks, and that's a lot cheaper, but not for those more distributed and less dense developments. But helps at hand. So all water companies are now required to offer an environmental incentive to developers. And encouraged to take this stepped approach of reducing water use, encouraging reuse of water, and then the offsetting of the remaining amounts. And actually, in fact, Thames Water led the way on this with their scheme that's been in place now for almost 3 years, and offering quite substantial sums of money. And in fact, the amount that they're offering, I think, is £2,500 for incorporating reuse. Is that? I'm looking at Mr. Yeah. So I'm just to point out. So I would say the cost burden might not necessarily be truthfully there if done at the point of construction and at scale. I'm pleased to say that with enough badgering internally, I've managed to convince my company to follow suit, and we will be offering £3,500 per home as of, just to be better than them, right? So it is £2,500 plus £1,000 for the first 2 years to try and encourage those early adopters to it. This is trying to remove that financial burden. So we understand that there is an additional cost, and also, and no disrespect to developers, but they have a very fine-tuned model, and changing that model has a cost to it. So we need to remove the additional cost of the infrastructure in the first place. Right, public perception. Well, and lots of people have told us it's the yuck factor. People don't like using everything. They like to be able to drink out of toilets, and now, quite frankly, I don't think people do. Can't possibly do this, but if this came about, I mean, the reason I started down this route actually was my son asking me the question that Nicky raised earlier: why on earth do we flush toilets with world-class drinking water? He didn't quite pose it like that, but I probably shouldn't use the language he used at the time. So we set about finding out what the public's perception was towards this. Well, we asked them about water resources challenges, fairly low on their prioritisation list, if honest. But then it started on, going into the whole, what's their understanding of the water resources challenges, and what are their perceptions towards the reuse of water in the household. I guess the big headlines are, it really depends on the source. Toilet to tap, not such a winner on their front. But the use of rainwater or greywater in the home, really quite up for it. It does also depend on what you're using it for. Putting it into their kitchen tap, not so much. Using it to flush their toilets, happy days. Use it to irrigate their gardens or to wash their clothes, interested in it. And I think over 80% saying that they'd be happy to use rainwater for the flushing of toilets. Says to me that maybe the public perception argument isn't so strong anymore. But there's a problem. And we mentioned it earlier, Sam alluded to it. We have regulations dating back to 1991 that basically control the water industry on this. 1991, we were in a very different place when it was the water industry became privatised. And we didn't have the water resources challenges that we now find ourselves with. That was back in a day where the majority of the water company had a shovel rather than the automated approach that we often have now. So we have a number of barriers, and I see lots of people taking photos of this. I can share these slides, it's not a problem, they'll be there. But yeah, we have these regulations in place that prevent us from doing so. Unfortunately, the Water Industry Act, primary legislation. Anyone that's been involved in policy making or legislation, quite hard to change. kind of like sort of the 5 years or more. And anyone that's seen politics of late will note that guaranteeing political starts for 5 years is quite difficult to maintain too. So we've got a bit of a problem because at the minute you cannot supply water, non-potable water or non-wholesome water for domestic purposes. The ways in which it's happening in Clay Farm and the likes, Clay Farm comes under a slightly different regulation because it's managed as a private estate and came under the local government's control, so it wasn't Drinking Water Inspectorate. Now, I should say that the regulators are really interested in trying to address this right now. In case you hadn't seen, this government are quite pro-growth. If you want to be in favour with government, you probably want to be pro-growth. So as a regulator managed, funded by government, you probably need to be getting on board the bus, which is why they want to see this happen. They understand that actually the water shortage and the crisis that we have, both from a water resources and a wastewater perspective, is such that we need to start embracing this. But we need to do it in a careful manner. And we completely understand that this is not about turning that reuse straight in toilet to tap, but it's about the right quality for the right use. And as Lutz says, it's done elsewhere in the world. So what we wanted to do is go, okay, well, let's gather those case studies together then. So if you want to know where there's reuse systems feeding residential properties, have a little look on our website. This is not everything. This is what we've managed to gather, and we tried to put the right facts in there around the information that we could get hold of. This is a work in progress in the sense of if you know of any others, let us know. We're happy to incorporate it. We've also pulled together a number of case study videos, some of which, in fact, a lot of which are shown upstairs. There's a little screen off to the side, not the one with Nikki's great big face across it. It's not a big face, it just happens to be big on that screen. There are a number of case study videos going on there which you can put some headphones on and listen to, but they're also on our website too. Just to try and get the information out there as to ones that have been successful. There are thousands of them across the world as well. We have produced lots of guidance materials. We did one around the economic benefits associated with it, which I think really got some political interest. As soon as you start talking about £20 billion worth of lost income to the UK economy, they start thinking this might be worth looking at. We also sort of pulled together the issues associated with the regulations and where the gaps are at the present time in terms of standards and guidance, and that's since there in our single source of truth document. We've put in various, positions into both there was a large review of the water industry, and we gave them our recommendations. And what was very nice was to see that come forward with it. In fact, our project was cited within that report, and have suggested changes to building regs as well through this, money of which align, I think, nicely with the UK Water Reuse Association. We've also produced a roadmap to say what needs to change and when. Now that actually needs updating because this hasn't all happened. So we need to update this, but it has got the conversation starting. There's a great piece of guidance, I should say, from Good Homes Alliance, which we co-funded, which looks at what, from an architect's perspective, or those designing these properties, how do you incorporate the sort of technology that you might want to incorporate, which is great. That's all freely available, and we've done a load of other stuff around skills, getting to Nikki's point around the fact that her plumber and her architect and maybe the builder weren't necessarily aware of everything about how do we ensure that the skills are, or there at least is the ability for them to develop those skills. So I would like to see us address this quite quickly. I am an eternal optimist when it comes to this, pessimist at home, optimist at work. I would like to see us embrace it, and I think this is the time to do it. So hopefully we can start to do it. And I think I'm starting to see, if we'd had this talk about 2 years ago, there would have been one man and his dog in here. It's fantastic that we've got lots of people in here wanting to see this move forward. So hopefully we can see this change. That's it from me.
Thanks, George. Okay, next up, Adrian Beaudremont. So Adrian is a senior researcher at Syria, leading on sustainable water management and biodiversity. Adrian has a background in environmental planning, water resources management, and nature-based solutions. He gained recognition for his management of innovative water quality improvements in projects in the San Francisco Bay Area, and then crossed the pond over to here to advance a suite of research projects involving SUDS, biodiversity, and much more at Syria. So I think Adrian's going to talk about the rainwater management platform, which is pulling together lots of good practice, guidance and things, and SIWEM is involved in that too.
Cheers. Thank you, Kat. Right, I'm going to try to keep us on time. Just have 10 minutes, and I have a few other bits to cover. So, well, first of all, Syria Construction Industry Research and Information Association, we produce guidance documents. So basically, we want to provide the construction industry with the knowledge to actually do good practice. So that's mainly what we do. And we have guidance documents. I'm going to talk a little bit about those. But we also have resources available that are more maybe in tune with what we've been discussing. And we have a community of practice, which is called SUSDrain, the Community for Sustainable Drainage. And I am going to talk a little bit about that before moving on to our very exciting off-road innovation project, the Rainwater Management Platform. So, on this screen, you have a lot of very lovely pictures. This is a little bit of a snapshot of the resource you can find on susdrain.org. All that is accessible for free, and it's basically a series of case studies where you can see what has been done and how to use those learnings for your projects. I have the titles here coming up on the screen. Just want to highlight on the right-hand side, this is our overall winner for the SUDS Awards 2 years ago. And you can see this is a rainwater harvesting reuse system that was put in place that is feeding all the toilets over there. So it's a lot of flood risk attenuated, but also, of course, potable water that is being saved. In the middle, you can see some entries in case studies. Some of them I was very pleased to see were actually downstairs, so you will recognize some of them. The community-centric rainwater management, the lower floods in Waltham Forest, a SUSDrain case study on connecting water butts underground and providing these for irrigation, very interesting one. And I just want to give a big kudos for the Blue Heart team that won the SUDS Champions Award last year. We were in Bristol and they were commended for their outstanding team. And I know some of them that are part of this effort are in the room today, so really congratulations for that. And we also have a lot of case studies that you can sort per device. So if you sort per rainwater harvesting, you will see many case studies, including this one here at the bottom left, which is Pave the Way, which has a lot of the whole portfolio of SUDS as well as rainwater harvesting in it. So I just wanted to point it out that, ta-da, this is a bit of a self-promotion here, but the SUDS Awards are open now. So if you want to apply, here's the QR code, free to apply and to attend, and we're looking forward to hear all about the amazing project that has been done in the industry. We also have guidance on rainwater harvesting within some of our documents. Here on screen you can see we have the water-sensitive urban design, which is very high level. It's more of the why and how to bring together communities and designers to think about how to integrate water within a landscape. And then we have the SUDS manual, which is our most famous document, I would say. And it has a section on rainwater harvesting that covers gravity-fed, pumped, and hybrid systems for water supply and surface water management. You have the calculation methods, hydraulic design, etc., etc. But what I want to talk to you today is actually the evolution of the SUDS manual. We want to transform this resource that has been used throughout the industry into something that is truly accessible And that is not this static document, 1,000 page, either printed or PDF, but something that can be really tailored for the user's need. So we recognize that since the last iteration of the CERTS manual, it's been 10 years now, so a lot of the technology has evolved, the context has evolved as well, and the way we actually access guidance document has evolved. You know, we do everything now digital, from our screens, our tablets, our phones, not so much scrolling through a 1,000-long page PDF. So we wanted to try to test new technologies to accomplish this. And so we got these grants from the Ofwat Innovation Fund, which is fantastic because it gives us the opportunity to do so. The idea behind this is to update the body of knowledge, which is the CERTS manual, with all the new context, technology, and learnings from the past 10 years, and then to serve it in a way that is really useful for a different set of users. So we want to cater not only for the construction industry, the drainage engineers, the water companies, but also reach the homeowners and all those who want to learn about what is actually rainwater harvesting, what is rainwater management, what can be done on any type of sites. And to do so, we want to leverage smart technologies. So the idea is to have a smart layer that will interrogate the body of knowledge, and then that will serve the response to the questions based on the needs of the user. So it's probably going to be some sort of AI baked in there, but the idea is really to try to make this guidance accessible and to get directly to the point that you are searching for instead of having to go through a massive document that has a whole range of different levels of technicalities in it. And here on screen you can see the outputs that the outcomes that we are trying to achieve through this. And one of the main one is the uptake of more sustainable drainage system, more rainwater techniques within the industry. There's a lot of people involved here. We got the support of the UK Water Industry Research, which is fantastic because it represents all the water companies in the UK and Ireland. So this is brilliant. Wessex Water is our champion here, and we also have SIWEM is part of this project, so taking care of the governance aspect. And then we have our key stakeholders and regulators. All of them are included within the effort to take a look at what we are producing, the direction we're going to, and steering us in the right direction. And then we have our expert delivery team. You will recognize some of the names here, which were involved in the previous CERTS manual, but also are very well known within the industry for their expertise throughout the sustainable drainage and rainwater management theme. And something that we started actually yesterday was the first one, but we have a series of user groups that are helping us identifying the needs of the potential users of this platform. And so we want to make sure who we want to cater for, what are the needs, who are those users, those persona as we call them, and how we can best respond to their needs through this platform. So this is ongoing. We are also, we want to make this a free and completely open access for the next 5 years once it's been released. So this is what we've put in the bid, and we really want to achieve it, trying to remove the barriers for people to actually get into this, and learning about everything about rainwater management. We will leverage the online format as well. So a little bit like George was mentioning, having videos to convey good practice guidance is very relevant in this day and age, and we want to have more of those. So trying to use different type of formats within this platform. And hopefully we will create the single source of up-to-date good practice. Just a little bit on the next step. This is my last slide. We are updating the content now, working with our team of authors. And the technology and platform is being researched. And little by little, we are selecting what technology is going to be used, and then it's going to be developed. And we will have late summer a first version. We will use our SESDRAIN community of practice to get in there, break it, and give us all the learnings we can get. And then little by little, we will create a platform throughout 2027 that will be released and available for all to use. And I'm going to stop here. Thank you so much.
Thanks, Adrian. Look forward to seeing that coming live. So finally, on my panel, Dr. Sarah Bunny. So Sarah is a strategic leader with over 25 years of experience in flood risk management, and also she has a PhD in emergency planning in the water sector. She is co-founder and CEO of Our Rainwater, and she's leading the company's transition from a consultancy model to a scalable software as a service platform, driving AI-driven solutions and data-driven strategies to optimize stormwater management. And I think she's going to talk a little bit more about that now. So over to Sarah.
Right, good afternoon, everybody. I can actually see over this lectern, which is quite an achievement for me, being challenged. Right, let's get started. Okay. Now, I actually want you guys to do something now, because I don't like people to be sat around listening and not doing anything. I want you to imagine a world. Okay, imagine a world where every raindrop is a precious resource and not a potential threat. So just close your eyes and just think for a minute. What does that mean to you? What do you imagine when you close your eyes? Okay? Now, we know this is achievable. But it requires us to rethink how we design and manage our urban spaces. Now, as the rainfall becomes more intense, we've talked about that a lot today, and less predictable, the way in which we deal with rainwater can no longer be passive, it can no longer be incidental. It needs to be intentional, deliberate, and designed for long-term performance. So, hello. So I'm Dr. Sarah Bunny. I'm CEO of Our Rainwater, and we're all about transforming rainwater management for a climate-resilient future. Now, we do this by working together with water companies, local authorities, housing developers, and communities to help them manage rainwater more effectively. Now, in practice, to us, this means 4 things. So the first thing we do is we sit down with our client. What is the problem you are trying to solve? Is it to reduce sewer spills into the waterways? Is it to reduce surface water flooding? Is it increasing biodiversity? Is it all of these things? Or is it something completely different? What we then do is we model a range of different interventions so that we can understand which solutions are cost effective, which solutions are suitable, but also where they should be located. And we do this using our AI optimization modeling. Because very simply, and I know my technical director will kill me for saying this, but it's not a simple process, I should say, but we want to put the right intervention in the right location so that we can meet the objectives of our clients, but also help them to solve the problems that they are trying to solve. Now, we do that across retrofit, but we also can do that modelling across new build developments as well. Now, once those interventions are installed, we then put monitoring on them because we want to understand how do they work under real rainfall conditions. And then we put all of that data back into our modelling to help inform our modelling further. But then what we also do is we provide that data to our clients as well, so they can use it to inform their decision making. Now, where a lot of water companies and local authorities are providing householders with free rainwater tanks to slow the flow into the drainage system, we also do a lot of engagement with householders as well. Because we want them to understand, okay, what is the problem that we're trying to solve in your local community? Why are you being given a free rainwater tank or a rain planter, whatever it may be? What is the problem? How could you potentially be part of that problem if you're not managing your rainwater correctly, or if you are putting things you shouldn't down the toilet. We cover lots of other different issues as well, but also how can you be part of the solution? But what we also do is we work together with householders to make sure that they understand how to manage and to maintain these rainwater management systems that they've been provided with. Because what we want to do is to make sure that they're operational right across their lifespan. And this is very important because obviously you don't want this whole fit and forget approach. So what we've learned from delivering rainwater management on the ground is that effective rainwater management only delivers real impact when it's treated as managed infrastructure and not as a fit and forget installation. Now, once you start delivering rainwater management at scale, the question isn't whether a particular asset works on a given day. It's actually, how does the system perform as a whole over time under operational, environmental, and organisational constraints? And this is where monitoring becomes very important, but where it's also very often misunderstood. Monitoring on its own will tell you what is happening. Linking it back to design intent, linking it back to the modelling that informs that, then allows systems to be managed deliberately and not reactively. Now, without that connection, data risks becoming something that you respond to after the event, rather than something that's actively informing how that system operates and performs over time. Now, the opportunity as we see it is turning this insight into reliable long-term solutions that organisations can depend on. So in practice, this means designing for performance right from the outset. So this is why we do our AI optimization modelling. Right solution, right location to meet the objectives of the problem that the client is trying to solve. Managing these systems over time and being accountable for the outcomes. Now, this shift is what enables rainwater systems to function as dependable infrastructure rather than a short-term intervention. And finally, we're solution agnostic because we know that there isn't a one-size-fits-all approach. No solution works everywhere. There are a lot of different variables when you go into different areas, household constraints, property constraints, location. It could be context and objectives differ from project to project. And we know there are a lot of really good interventions out there on the market, some really good ones. But what there also needs to be is a consistent way to understand performance, okay? How we manage risk, but also to support decision making. And this consistency is what helps a rainwater to be managed with confidence. It helps it to be managed at scale, but also for the long term. So thank you very much. I just wanted to put a few ideas out there, food for thought, as we move into the panel discussion. Thank you.
Thank you. So can I invite my panellists up? Going to have a bit of a chat about that.
Lie on the front. Yeah, okay. Oh, right.
Okay, so I have a few questions for the panel before we dive into audience questions, but I do want to make sure we give time for audience questions, but I do have some things I want to pick up first. So, George, you touched on the public research that had been done through Enabling Water Smart Communities and this idea that people are okay with rainwater to tap, but maybe not toilet to tap. Were there other misconceptions? Do you think there are other misconceptions amongst the public? And I'm going to also opening this up to the whole panel, actually, because Lorna, you've done a lot of engagement with people as well, and Sarah as well. So just want you to sort of reflect on what are the other public misconceptions with these kind of systems.
Okay. Thank you for that question, Kat. I hope you're thinking about that. Okay. So I don't think the majority of the public know actually where most of their water comes from. So maybe I'm not going to ask for a show of hands because that's not going to go very well. I can't think what the question might be. But I don't think the majority of the public know where their water actually comes from when they turn on the tap. But what they do is they tend to trust it. And hopefully they can trust it because we have world-class drinking water in this country. And we are very lucky to have it. So the fact that they don't trust toilet to tap, if you're drinking tap water out there, it's gone through, is it 6-7 times, we reckon now? I mean, it seems to go up every time, which is kind of understandable. But it's made its way through someone before. And is that nice? I'm just seeing the cringe by Nikki. She's like, well, I think I'm turning to bottled water. Yeah, that's true. The fact is that we seem to find it absolutely fine to put it through a sewage treatment works, discharge it into a river, and then abstract from that river a mile or two downstream. And apparently that's better than taking it straight from the sewage works. That feels odd that we put it into a river. So I think there's an element of not understanding that. I think there's a misconception, though, around how dirty some of this water is as well, associated with it, and the risks, the health risks associated. We can't just be blasé about it. We have to understand what those risks are around misconnections. The key is trying to make sure that we can identify those misconnections quickly. You quickly identify if your gas is misconnected. It's less easy to find out if your water is disconnected. It just might have a slightly weird taste to it.
So it's just making sure we've got those systems in place, isn't it? And that people understand and trust the system as well.
So, what? She's just giggling at me. I don't know what I've done wrong.
It's a good job you're not in charge of public health, George.
There is a very good job that I'm not. So I'll pass over.
Lorna, you were from was it 11 years at South West Water?
Yeah, she was like, I would not employ any strategic comms.
I think that there's definitely a case for some clear thinking here, because we are already doing what it's got a very confusing title. It's called indirect potable reuse, which I find very confusing, really, because we're actually reusing impotable water here, but what that means is putting final effluent into either the conveyance system, the river, or the reservoir, mixing it with all the other sources that go into that river or reservoir, taking it out, giving it some advanced treatment, and then putting it back into supply to drink. So that's indirect potable reuse. And that's what California's been doing, other places, with lots of success. And I know that already happens. I live downstream of Sarah.
Oh, God, what's Sarah been doing in her house?
No, I'm Somerset.
I live downstream of Tiverton. They put their final effluent in the River Exe. It comes down the Exe and it's abstracted at Pines, where it's treated for my drinking water. So it's had a nice little trip down the Exe in the meantime. And my drinking water is tickety-boo. So I think this is happening, and I think we could overthink how much public engagement we actually need to do around this. Maybe we just need to get on with it. Actually, the final effluent is a useful resource, and how much asking people what do you think about that do we actually need to do? I suspect perhaps we don't need to do very much. And likewise with new developments. Do you want to have a separated source for your toilet flushing or not? Who cares? This is just how we're going to do it from now on. I think we should just say we need climate resilient houses, we need water resilient houses. You're getting a house, a lovely new house, with a separated supply for your toilet flushing, and that's okay.
Can I just? Sorry, this is really harsh. Ooh, this is slightly louder. So I remember growing up where you didn't drink from the upstairs taps because it came from a water tank and you didn't know what was in that tank. Yeah, exactly. What we're saying is don't drink from the toilet bowl. I don't think it's crazy, is it? to be just encouraging you not to drink? Well, maybe I'm just naive.
A certain amount of getting on and doing it, is it? Sarah, I might just change the question a little bit because for you, you've been doing a lot of monitoring of these systems and looking at how consumers are engaging with these systems. What do you take away from that? What have you learned?
Well, I was ready to answer the other one, but I'll think about that in the background. But I was just going to say, coming at it from a stormwater perspective, flooding is very visible. So a lot of people do understand flooding in their local areas, but they don't necessarily connect that to capturing rainwater from their roofs. What they do in their gardens, if it's, if they put paving over it and where that water, so it comes back to George, they don't actually think about where the water goes. So there isn't that connection, what we're finding, between stormwater management or capturing the rainwater and reducing sewer spills, for instance, and those kind of things. So there's a lot of gaps, I think, and a lot of education that could be done. What was your other question, sorry, about the monitoring? Well, that's an interesting one.
Insights into consumer behaviour and engagement.
Yes, there are actually. We're running a campaign at the moment in Kensington, with Kensington and Chelsea Council. And this has been a really interesting one for us because this is a council that is very engaged with the community and the issues that are going on in the community. They've also experienced a surface water flooding in the past, and we're running an engagement campaign with them at the moment, and we're finding that the community is really engaged. They really understand they've experienced flooding, so they do understand what the challenges are. But going into that community and talking to them, my team are out there today, talking to people who run community gardens, how they can capture the rainwater more effectively. They're working with other community groups, they're talking with householders. So once you start engaging with people and you start asking the right questions, I suppose, and helping them to understand, they do become really engaged, and then they become really enthused, and then they actually want to be part of the solution and making a difference. But you have to manage it carefully, I think, because I know water companies, sorry George, but you're not viewed very positively sometimes by the public. It's not your fault. It's not your fault, George. I know. But, we have to be careful on how we communicate these things as well, because I have also, shortly after the first announcement about Thames came out, I was accused, because I was working on the community-centric rainwater management project that Adrian put up, we won an award for, with Thames. I was accused of being a criminal because I was working with the water company. But I then explained to that person, who was very, very angry and very aggressive, but I said, the climate affects all of us. And the climate is changing. Rainfall is becoming more intense, and we need to find ways in which to manage that rainwater effectively. It's, Thames Water aren't in control of the rain. So, there's ways in which to communicate that, and I can communicate that because I'm not the water company. But, yeah. So I'd say, a mixed bag. Yeah.
Thank you.
Adrian, yes.
Just want to add to this. This is, I think, community engagement and how we communicate about the linkage between rainwater and everything else, what comes out of the tap, is really key. And so one of the aspects that we're trying to do through the SUDS awards that I briefly mentioned before is to recognize what is being done and to try to put the word out there on what is possible and how to achieve it. So it's and the rainwater management platform is also trying, in a way, to try to reach that point as well, where we can actually use it as a resource, not only for practitioners and professionals like we are, but also for education purposes, and to talk about the value that we can get out of this rainwater. It's not just the rain that falls on the rooftops, but it's what it provides in terms of quantity and the flood risk that comes with it, but also the quality, how we can improve the quality of it if we use it correctly. But also we can create biodiversity places for people and amenity out of it. There is a lot that can be conveyed to try to change this narrative on how rainwater is actually a resource, something that we can value and we can build upon on top of it.
It's definitely something about changing the narrative. Okay, I think we should open up to the floor at this point. I'm sure there's lots of questions, and I can see one there at the front. Do you need a mic?
Yeah, cheers, mate. Cass Hassel, ECH2O. So, Nikki, I know she's not on the panel, but she talked about like needing to find some plumbers for her rainwater harvesting system, and I just wondered if anybody on the panel was aware that BPEC, British Plumbing Employers Council, have had rainwater harvesting training in all colleges since probably 2010, which I co-wrote and trained up all the trainers for. Yeah, so there was a point where we were doing that. Yeah, okay.
Yeah, I mean, it was linked to COPE, sustainable homes, or rather aspects. And I think the key there is it's available, the information's out there, but we've got to make sure that people are doing it as well. And that hasn't been the driver, and I think, sort of Nikki made the point of, we've got to create that driver for them to want to train up. Yeah. But every day that a plumber is at training, they're not getting paid for the jobs that they're doing. So we've got to make it worth their while, taking a day out or 2 days or however long the course takes to warrant doing that. So the material's out there, and no disrespect to those that are technically delivering stuff, it is not rocket science, but it's not a DIY job right now. You do need to train up, you do need to understand it. There are health implications by getting it wrong. So
that's brilliant, George. That's great. So are the water companies looking at paying plumbers to do the course? Because I used to be in the plumbing industry. Yeah, everyone's always saying like, oh, you're the ones who are going to save the world, right? But they never give us any money to go and do the training, and that's exactly what happens.
It's an interesting idea. It's one that we could possibly look at, is to get the plumbing. So I know that there is a large push on trying to develop up the skills. The Drinking Water Inspectorate are about to put out a publication. Shortly they brought together an expert group, a very secretive expert group on water reuse that came up with a series of recommendations. My understanding is that out of the back of that, they are proposing to the qualification associated with the plumbing trade around water reuse. So let's see if that leads on to, and then how do we actually ensure that people are getting these qualifications? So it's a good idea, Kath.
Can I come in on that?
Yeah, you come in, Laura.
Well, I've got a slightly utopian vision, which was sparked by talking to Affinity Water about their Ofwat project that I think stalled. Are Affinity here? Yeah, I think it might be you. Yeah, water companies install Sam's system or others, communal rainwater reuse systems, and adopt them. The water company adopts it, just as they adopted private sewer systems, and then that whole system they will set the standards, the training needs, and drive that whole maintenance process by having the knowledge and the muscle and the heft of a water company behind it. I think that would push forward the whole kind of new build reuse agenda, and plumbers would be swept along with that, and that would be good news, I think.
And to build on that, I think if the government were to set their ambition as including water reuse and rainwater harvesting in building regulations, that would then set the ambition for the water companies, and then that would flow through to plumbing training and the supply chain. Okay, more questions?
I already have it. So, this feeling of power, it's amazing. Okay. So Andrew from Thames, we've had that environmental incentive for a few years now. So money incentivizing, get the right fittings, get some form of water reuse into the equation, offset the rest, we'll deliver it for you, be water neutral, pound signs. But take-up's really low. and it comes back to the desirability. There's no demand, there's no requirement. So I would say that whilst carrots have a role to play, it's absolutely not going to shift the dial. It is absolutely not shifting the dial. Where it is working overseas, you've got a stick. Okay, it's either a planning requirement or it's a building reg thing. Other mechanisms may be available. We've had Part G consultation from DEFRA on the fittings element. Apparently there are 2 more phases to come, and I believe phase 3 is water reuse. With all the guidance that's out there, whether it's for building regs or planning, could you write what's required to go into those sticks?
I think we have to. I think we have to feed. I'm going to say MHCLG, but we all know that they've basically given it to DEFRA to try and do on their behalf. So hopefully we can write that, and I think we need to do that to help them on it. You are right. I mean, ultimately, building regs isn't the baseline. It's what everyone gets to, and they don't go beyond it, and we need to be incorporating it. And I completely appreciate that you put a carrot out there and it hasn't been taken. My point was, we can put as many carrots out there, but it's not actually shifting. That's not the big blocker that wants us. I think it needs that stick, as you say, and we need to enable water companies to potentially adopt it. I think the biggest barrier is stewardship and adoption. I'll shut up.
I think we've got 5 minutes. So another question.
Hello, I'm Carolyn Hogg from Cascade Water Products, and I've got a whole load of notes out of this conference today, and it's been very good. Going back to when Nikki started, and she was talking about enablers are not in place. But today, we have got enablers in place. Now, we're talking about greywater reuse, and that's my speciality. It's not whole building blocks of flats. It's not community system. It's a domestic system, one system per house. We've spent 10 years developing this system. So yes, it's taken a long time. It's been working in my house for several years. 2017 was when we fitted our first prototype. But we've had so many barriers. We've talked about barriers, and living in Scotland hasn't helped because greywater reuse is not necessarily seen as important, but down here it is. Well was mentioned. So I would love to apply for WELL, the Water Efficiency Lab, but I need people to help me. I need you people here in this room to enable me so that I can have sites to put our system in so we can then monitor them and create as, sorry, Bunny, I've forgotten you, as you had described in your thing, so that I can produce data. So that you can then have the data so you know that where there is a house being built, where planning permission is not being allowed, it can then happen.
Okay, see Caroline after. Carolyn after. Any more questions? I think we can take 1 or 2 more quick ones.
Hi, it's Janet Manning. I spotted at least 2 slides with flower shows on the, photos of flower shows in there, but we haven't talked much about gardens. And when it comes to messaging and getting the public on board, or even persuading anybody, I would really like to persuade people to think, okay, we've talked loads about tech and pipes and pumps and tanks and treatment systems, but if we really want nature-based solutions, then we need to think back to what would happen if we weren't here. Then it would be the soil and the plants that were doing all the treatment for us. And that gives you a really good platform to engage with people, to explain what the water cycle would normally do. Lots of homeowners have got a garden right on their back doorstep and they want water for it. It's a really good engagement platform to be able to get those messages across. So 2 questions really for the panel. One is, when are we going to see SUDS features as domestic gardens, or the other way around? When are we going to see domestic gardens considered as a SUDS feature? And are we also going to be wary of emerging pollutants that might be coming in when we're talking about water reuse treatment? What about emerging pollutants like things like PFAS? because that's another big issue.
Okay, quick fire answers. Adrian, do you want to pick that up on gardens and suds?
Yeah, very quickly. So 2 years ago, we had the Suds Awards in Cardiff, and we were very conscious that we wanted to put the light on private properties and see what people were actually doing in their garden to capture, to slow, to infiltrate, and to treat the water where it lands, which is, for us, one of the key things. And the response was incredible. We got a lot of really interesting gardens, actually, that were really water tolerant and that were using all that resource really well. And so we're trying to continue on that trend, and we have a dedicated category in the Suds Awards, and all those entries are accessible for anyone who wants to just take a peek and get inspired within their own back garden and say, okay, I want to put a water bird here. I want to do something very simple, passive, no blinking red button, something like just gravity fed. It's going to leak a little bit. It's going to retain the water for a while. You'll have something to water your plants when it's dry. So, yeah, there's a lot of example out there. So hopefully that might help. And then PFAS at Syria, we have. I have a colleague that is working on contaminated land, and she works a lot on PFAS, trying to find the good practice guidance on how to capture it and then what to do with it, and to better understand it as well. As a business, I would say, as a first step, so working a lot with large infrastructures that have a lot of road runoff, but I think it's gonna, as it is more and more studied, maybe this is something that will reach more of a public audience. So I'm going to stop here.
Yes, I know the picture that I put up at the start, we were involved in the Chelsea Flower Show 2 years ago, I think it was now. And yes, and the thing that inspired me by seeing that garden and how that garden was designed was everything was achievable. And I knew I could look at the plants, I thought, I recognise that one, I could do this in my own garden. I could, and I'm going to one day because it was very inspirational. And yeah, and we do a lot of work with community gardens as well to try and sort of work together with them on how they can collect the rainwater to help them water their gardens, but using it as a flood, what would you call it, a flood attenuation system, I suppose, like the climate resilient garden. I mean, that's just so exciting. And I think that, yes, if we can encourage more people to do that, I think, yes. But it's, I suppose, the other thing is showing people how they can do it as well, because the flood resilient garden, they did have a list of all of the plants and everything that you could use, but how do you do it? That's the...
So if only we had like a Royal, that's it, Royal Horticultural Society.
Yeah, they would be good.
I think that we have, the RHS have so many members. I think there's a role there. As you well know, they've got a great campaign that was led by the question asker here, Mains Terrains, which is trying to encourage exactly that, to try and utilise the rainwater for irrigation purposes in the garden, but also, the garden has a real role to play in this. And I'd really like to see the RHS embrace this. They have huge amount of outreach here, and an avid membership, and I think there's the whole. Let the experts practice as they preach as well. But you kind of no, sorry.
And I think coming back to that as well is we install a lot of rain planters as well, and it's getting the right plants for those as well, and getting people to understand. But having said that, I'm just thinking about Lambeth. I walked through there and we put some planters in with the community-centric project, and people are growing all sorts in those. I saw tomatoes, I saw peppers, I saw all kinds of things, and it's just really hard. Yeah,
slightly differently.
Yeah, but it was brilliant because people are taking ownership of it, which is what we want. We want people to take ownership of rainwater management in the same way that we took ownership of recycling, everything in our houses. So yeah, I think it's inspirational actually to see what people can achieve.
Great stuff. Okay, we've got to wrap up. Can you just give me each a sentence on what is the one change you'd like to see in order to get this stuff scaled up and mainstreamed? One sentence only.
Let's change these regulations to allow for non-potable water to be supplied for domestic purposes.
I think the regulations are moving in the right direction, but I think there could be more ambition. Having said that, I do think the government is tackling some of the low-hanging fruit, which is right. That was one sentence.
I've got so many things in my head right now. Okay. No, that's not fair, George. So regulation, yes, I totally agree with that, definitely. But I also think as well that we need to make people more aware of what the challenges are and the things that they can do, following on from Janet really, on what they can do to actually be part of the solution. I think that's so important because it's a journey we're all going to take. Climate change doesn't affect, the water companies, it affects all of us. So, how do we manage that? How do we get everybody engaged? Sorry, that was a lot longer. I apologise, Adrian.
Okay, that's challenging. Let's become Belgian. Mandatory rainwater harvesting reuse systems installed in every new build.